yourselves mute.
Okay, powerful morning sa ating mga kaguruan mula Luzon, Visayas at Mindanao, maging sa mga kaibigan nating guro mula sa ibang bansa na patuloy na nakaantabay sa ating mga webinar series upang magbigay karagdagang kaalaman sa kanila sa paghahanda sa new normal of education this coming school year. Okay, this morning, we are now on the third series of our webinar, and today, we will discuss the use of TinkerCAD in promoting coding and robotics. Later, we are going to introduce our resource speaker. And today, we have a special guest from the USA na ipapakilala sa atin ni Ma'am Maylene Aviva. But before that, let's start the day with prayer and a short message from the head pastor of Jesus the Bread of Life Church, Pastor Sunny Medina. Pastor Sunny, good morning.
Good morning, a powerful morning and a pleasant and blessed morning to everyone. Hello again, happy to see you all. And good morning to Ma'am Maylene Aviva of Felta President and Ma'am Jenny Lou Pangilinan of STEAMified Learning Center, Wax Benson, the chairman of Power. And also, I'm saying hello for the first time to Sir Peter and Ma'am Isabel of Gearbox Labs Local Laboratory. Thank you and good morning. Thank you for having me again. Thank you for having me here on live webinar on using TinkerCAD circuit to promote coding and robotics. So while Chairman Wax Benson assigned me to have an opening prayer on this live webinar, so what struck my mind is the word tinker. Just like a thing. It sounds like a thinker, okay? So I come up with the word future thinker. So God is the future thinker because he know everything in advance. If we read the Bible, and you will know why God is an advanced thinker. So actually, we are the product of his advanced thinking, because we were created in his own image. Therefore, we have the mind of God. That's why most human, we are pure thinkers. So mostly humans are thinkers. So our mind can travel faster than the bullet. Don't you think? So some says this command tower is very dangerous. That's why the Bible reminds us in Romans chapter 12, verse 2, that be ye transformed by the renewing of our mind. So it must be surrendered to our God, what is inside our head, because you are what you think. So it must be used to become a better you. So because God created us pure, righteous, and holy mind. So a writer once said, sow a thought and reap an action. Sow an action and reap a habit. Sow a habit and reap a character. Sow a character and reap a destiny. So you are what you think. Be a future thinker. Your destiny is to succeed. Okay, let's pray. Father in heaven, all-knowing God, thank you for creating us in your own image. Thank you for the sound mind. We entrust to you everything, Father. Bless and give more knowledge and wisdom to our moderators, and most especially the resource speaker, Dominic Sales. Make this webinar more interesting, Father, to all listeners. Bless this webinar from start to finish. In this all we pray, in Jesus' name, amen. Thank you very much, and God bless you all.
Amen. Maraming salamat, Pastor Sunny, for that very motivating message that we have to start the activity with a prayer, no, for the guidance coming from our Lord. Thank you, Pastor Sani. Of course, I have with me again, Ma'am Jenny Lup Pangilinan Riel and the President of Felta Multimedia, Madam Mylene Abiba. Magandang umaga po sa inyong lahat. So, what do we have for today? Ano bang meron sa atin ngayon?
Well,
Ma'am
first
Jen.
of all, Miss Jen,
Yes,
ikaw, agenda muna.
Ako, agenda mahaba,
Yes,
kaya
Ma'am
si
Jen.
Ma'am Mylene muna. Para ma-introduce na yung ating guest kasi gabi sa kanila, no?
All right. Well, for the first time, since we've been conducting the live webinars, we have a live international guest with us this morning. Well, it's evening at their time. We have with us our principal from Gearbox Labs, USA. They are the producers of cutting-edge STEAM education resources and the curriculum called the Arduino Classroom. They teach engineering design, coding, and a lot more for the schools in the USA. They're based in Wisconsin, USA. May I introduce to you Mr. Peter Haydock and Isabel Mendiola to say a few words.
Yes, good morning, Sir Peter and Ma'am Isabel.
Yan, nakamute sila.
Yes.
Naka-mute. You're on mute. There.
Oh, loading din.
You're on mute.
Can
All
you
right.
hear?
So
Yes, okay.
Oh, there you go.
go ahead, Peter and Isabel.
Thank you for having us. We're very excited to be here with you today. We started this company about a year ago, but really had the genesis of the idea more than 5 years ago when we saw that the schools in the United States were not embracing coding, engineering, and
Connection.
Kala ko ako yun.
So
Connection.
They're back. Okay.
I started in Mexico my career as a teacher, teaching physics, biology, and chemistry. So that city in North Mexico is a very industrial. So the schools were looking for curriculums with more engineering. So I had the opportunity of at that time teaching
Balikan
technology.
natin siguro.
So what I did, I introduced Arduino to my students. So we started designing digital design using TinkerCAD. So since they were so scared to use wires and the microcontroller, so we started with the digital design with what the TinkerCAD. So that way they started building their own prototypes, and that way we could go to the next step until they could build more complex prototypes. So by the end of the third year, they were ready for building pH sensors, for chemistry labs, sensors for frequencies, for testing frequencies in physics, and different type of prototypes. But the base was TinkerCAD. Yeah.
And we're excited when I found Isabel and we were talking about the curriculum. Countries like Mexico and Philippines and even places in Africa are further ahead than the United States. So we brought these concepts to the U.S. and we're very excited to bring them to dozens of schools already in our first year. We're really excited, and we give you all the thumbs up for your studies today.
Wow, very inspiring. Thank you very much for staying up late to watch us. And we're looking forward to working and collaborating with Gearbox Labs USA for the Philippine schools. All right, I think back to you, Ms. Jen. All right. They'll be watching, but they'll still be in the show, but they'll be watching until they get sleepy. All right. Okay. So back to you, Miss Jen and Sir Wax.
Okay, for our participants to know, Gearbox Labs USA appointed Felta-Multi major expositor for the Arduino classroom in the Philippines. So congratulations, Felta, for having the Gearbox Labs to collaborate and help our educators regarding robotics. Jen.
Hello. Okay, so bago mag-start ang ating speaker, I will have to show my screen. Sir Wax?
Okay.
Okay. Live na ba? Sorry. Madaming ba? Okay, so lakihan natin para makita ko kayo. Hindi ko kayo kita. Okay, so we are having TinkerCAD circuits for today. So before we do the actual lesson, kailangan ulit nating magbigay ng background. Why are we even doing this? So when I started teaching STEM, ang focus po talaga is how can we build a career pathway for kids and how do we make it happen for them and how do we help them realize whether they are fit for the STEM fields, particularly in the robotics strand. So tingnan natin. So we're gonna have nadoble ako. We have robotics engineers, and who are they? We are going to look at how much they earn. Is it worth it to engage in robotics? We have to learn the basics. How can you start learning? Hindi pwedeng learn agad. Kailangan may planning ahead. And how do we complete that? And then we'll go to our resource speaker lesson proper. First is, let's look at what are robotics engineers. Who are they? So robotics engineers are engineers that plan, build, and maintain robots. These engineers plan how robots will be used in terms of using sensors for detecting things. They design, they construct, and they program robots. They install peripherals, and it's allowing the robots to do specific tasks. Paano ba magiging roboticist? Yun yung term nila. Paano ka ba magiging engaged into robotics? So, ang iisipin lagi nila is, kailangan ba, paano pag may age, medyo seasoned na ako, hindi na ba ako pwedeng mag-robotics? Pwede. So, walang age na pinipili. Anybody can learn. Hindi mo kailangan maging engineer to engage in robotics. Like, accountant ako, but I engage in robotics. So, ayan. Sir Wax? Hello? Hello? Sir Wax? Hello?
Hello?
Hi, Jenny. We hear you.
Oh, I'm sorry. I thought I got disconnected. I saw an image.
But we don't see Wax right now.
Oh. He got lost talking. Okay, so ayan, I'll continue with it. So how much does a robotics engineer earn? So robotics engineers plan, build, and maintain robots. So it's a high paying job. And if we look at the salary scale, the low paying, this is in data from the United States. Most of them earn around $64,000 up to $116,000 a year. So this is the annual salary scale. So if we look at the trends, who are hiring roboticists or robotics engineers? So private companies, local governments, state government, and federal governments are the ones who are responsible for these engineers to be hired. So ito yung trends nila. So some of them earns $20 per hour up to 70 to sometimes 100 plus. It depends on what you have. as credentials. Okay. So how do we start learning? There are three phases for beginners. We have learning the basics of robotics, and then we build the skills over time, and then those who wants to really engage into robotics as a career, they study in an advanced level. So most of us starts with being having it as a hobby, and then we build our own robots. And for kids, for elementary to even college levels, we engage into competitions as well. Okay. The first thing is we start practicing basic coding. Coding is the foundational element. So ito yung why are we learning TinkerCAD? The basic coding can be learned through the TinkerCAD circuit software. The next will be, of course, you have to do math. You have to learn linear algebra. So the basic coding, the backbone of basic coding would be algebra and physics, like what Miss Isabel said. To prepare you for building robots, basic algebra is essential for programming the robot and tweaking the code. So kailangan talaga those who are listening as the elementary and high school teachers, you influence the career so much. So kailangan talaga we provide the students multiple platforms in teaching the subject. Also, we have to have physics. So building robots involves understanding on how robots move. So yung mga basic principles and how the robots will interact to the outside world. We also have computer science. So ngayon integrated na yung computer science in many um, fields. So computer science and the strong understanding of computer science will lead to the further understanding of the robotics lessons. Okay. So what are we learning today? We are going to learn about using TinkerCAD circuit to promote coding and robotics. So our speaker will be further later introduced, and then we'll have three parts. He's going to have the first part, which is the introduction to robotics and a tour in the TinkerCAD environment. The next part will be basic coding. He will discuss about coding and circuit design, working with buttons, potentiometers, buzzers, and LEDs. He will also add sensors to the device. And then later, he will have the integration part, which is the integrating of topics from other subjects for final outputs. Ayan. So if you have questions, again, you know how to reach me. And then let's go back to Sir Wax.
Thank you, Jenny Lou, for your introduction for our
Yes. I
webinar
was
today.
scared you got lost.
Yeah, I have problem with my internet. It was
Oh
disconnected,
my
so I
gosh.
have to. I got panic. I thought I could not. Anyway, we will continue as you mentioned, Ma'am Jenny Lou, about the introduction of Arduino. No, let me
Mm-hmm.
introduce first the video. Okay, let me see. Yan, nawawala yung video ko.
Later, I will also show it.
Sure. Yan, nawawala eh.
Share.
Nawawala. Wait.
I love the music for that video.
Oh no. Where's the video?
I don't know.
Nawawala yung video. Wait lang.
Sa akin meron. Ay, kaya lang hindi ko share.
May screen ka
Hold
dyan?
on. Wala akong audio.
Sandali nawawala yung ano ko eh. Biglang nawala. So this is
Meron
one of
ako.
the technical problem. Sige, share ko lang yung video.
Okay.
Kanina okay na eh. Ayaw mag-share ang video ko. What happened?
Play mo. Oh no.
Nawawala.
Hold on. I can share the screen. Wait lang. Try natin. Play ko sa akin audio sa'yo.
Ayaw lumabas.
Share screen?
Naka-share ba yun sa'yo?
Hindi.
Ah,
Oh, sige.
okay.
Try mo nga. Ayan na.
Sige, asa na?
Ay, akala ko ikaw. Wait lang.
Biglang nawala eh.
Okay. I have the introduction to gearbox labs ba? Eto,
Hindi, isa.
naririnig.
Yung isa, hindi.
Okay,
Ayaw
play ko na
lumabas.
rin to. Ayan.
Ayaw. What happened? Nawala kasi ako sa connection ko kanina eh.
Isa pa. This. O, play mo yung video mo. Ay, ang audio mo pala.
Sige, dali lang ah. 1, 2, 3. Okay, so that's it, no? Yan po yung video ng Arduino Classroom from Gearbox Labs. Okay, sorry for technical
Okay.
difficulties. Nawala kasi ako sa
Yeah,
internet
we
kanina.
were able to do something about it. Okay, so I like the gearbox kit, no? Kasi it contains all the essential tools you need to start learning the basics. So therefore, if we use the TinkerCAD like what Sir Dom will be doing, it's a simulation of the actual thing, no? So let's see what Sir Dom, and we can introduce him now probably so he can start.
Okay, so let us introduce our resource speaker for today. Okay, a graduate of Master in Information Technology, a certified Apple teacher, certified Microsoft Innovative Educator, and a Google Certified Educator Level 1, and a member of Philippine Robotics team. Ladies and gentlemen, our resource speaker for today, Mr. Dominic Sales. Good morning, Sir Dom.
Hello,
Sir Dom.
everyone. Thank you for having me here in our webinar, a free webinar today. Thank you, Felta, and thank you, Sir Wax, for the introduction. And also, thank you, Gearbox Labs, for our special guest for this webinar. Today, I'm going to show you how to create a basic application or basic circuit design using TinkerCAD. So in a few hours, we will start our discussion. I'm going to share my screen so that you can see my presentation.
Okay.
All right. I hope you can see my screen now.
Yes, it's
Yes.
clear.
All right. So again, welcome to this free webinar on how are we going to use TinkerCAD to promote coding and robotics. So once again, I am Dominic Sales, a master in. I have a master degree in information technology, and I'm also part of the Philippine robotics team. I'm teaching coding and robotics, and I'm also an edtech coach in Xavier School, San Juan. I'm a certified Apple teacher and a certified Google Educator Level 1. Okay, so once again, I'm going to show you on how can we use TinkerCAD to promote coding and robotics. So if you have questions later on, you may just type in our comment section here. Okay. So before we begin with our demonstration on how are we going to use TinkerCAD, let me just explain to you what is a simulation tool, because a TinkerCAD is an online simulation tool. All right. So simulation tools have found numerous successes and advantages in education, being used for teaching, training, and testing applications. Nowadays, these simulation tools are very, very much essential in our education as part of the education, because we really need simulation tools to show our students, to show our learners how things will work. Because of course we don't have the face-to-face education right now, or we don't have the traditional education right now. So what we are having is the online distance learning. So online or simulation tools are very much essential and very much needed for today's pandemic. All right. What are the advantages of using online simulation tool or simulation tools in education? First, we have here the interaction between learners. Okay. And the another one is we have the learning can be done regardless of time or place, which means to say that, for example, you were in your house or in a coffee shop or in a supermarket, as long as you have your gadget, your mobile phone, your tablet, your iPad, as long as you have this good internet connection, then you'll be able to join your class, join the community. All right. So regardless of time or place. And also we have here, learners can train and experiment multiple times. This means to say that it will lessen also your cost, money, because you can experiment multiple times without having this problem of messing up things. For example, in chemistry, no. So most of the time we break some materials, parts of our experiment. So using online simulation tools, you can experiment multiple times, less cost, and of course, it's cost effective also. Okay, so these are just some of the advantages of using an online simulation tool. Okay, moving on. Question here is, can you use coding and robotics to teach other subjects? Can you use coding and robotics to teach other subjects? So the answer is very obvious, right? So yes, the answer is yes. Use robotics to teach different subjects. Though there are different ways on how are we going to integrate our topics from other subjects. Okay, so I have here 3 subjects wherein we can actually integrate the different topics from these subjects using coding and robotics and TinkerCAD. We have the number 1, mathematics. So in mathematics, we can teach number coordinates, axes, degree angles, shapes, unit of measurements, variables, data types, and operators. Of course, in teaching coding and robotics, we need to know the different variables, X and Y and Z, the different data types, the different operators to be used in the equation, the axis, degree angles, shapes, different shapes, and unit of measurements, of course. And number 2, we have physics. Physics, as been discussed to you by our guest from Gearbox Labs. Of course, you can teach physics when you're doing coding and robotics. You can teach speed, velocity, force, displacement, and dynamics and control. So These are just some of the topics wherein you can integrate coding and robotics in different subjects. And also we have here science, wherein you can teach light by the use of light sensors, the color sensors, motion waves, heat energy, energy in general, heat monitoring, earthquake sensing. So since in Arduino, it's very Arduino has a large community wherein you can use different sensors. You can search from different resources, wherein all of those sources are 100% free. But of course, the sensors are not, they are not free, so you need to buy at a very minimal cost. So it's very cheap also. All right. So these are just some of the subjects or topics that you can integrate in teaching, and you can use coding and robotics to teach these topics and to promote learning to students. Okay. Moving on, I'm going to show you these two free online simulation tool that I'm actually using. So examples of simulation tools in coding and robotics. So though there are numerous numbers of online simulation tools when it comes to coding and robotics, I think these two are the best online simulation tools. In my part, these are the best free online simulation tools in coding and robotics. Okay. So first one, we have the virtual robotics toolkit. Okay, it is being used to teach also to integrate science, technology, engineering, and mathematics. Okay, this has a very huge community. Okay, so the virtual robotics toolkit comes equipped with several sample projects to get you started, a number of competition maths to hone your skills, and even provides tools to change the physics engine itself. So again, this is a free online simulation tool wherein it has different samples, several projects that you can start if you're a beginner. So it's not a problem anymore, since you can search, you can just simply copy the different samples and then you can try it yourself. Okay. And another feature of the virtual robotics toolkit is, in a digital space, you can easily mix and match bricks. So, which means to say that you have this huge number of materials and resources from various kits using your favorite design tools. And in a matter of minutes, you'll have your own creation working within the simulator. So you don't need the actual robot. You don't need the actual Lego robot. Okay. So you're really only limited by your imagination. Okay. So that's why, in using online simulation tool, all you have to do is to simply imagine things. Okay. You simply imagine things. What robot could be very beneficial for let's say, for example, during this time of pandemic. Okay, so you just need to imagine, you just need to be creative, and the materials, you don't have to think of buying materials. All you just need to do is to search the internet, the different free online simulation tools. Okay, moving on, the virtual robotics toolkit lets you store your creations as files. So this is one of the most important part of having an online simulation tool. The feature of will be able to save your files, of course, that live on your computer, making it easy to come back to a project at a later date. So, it's very important if you save your files. Well, some of the online simulation tools, it will not ask you to save your file. It doesn't have the feature of saving your files, but this virtual robotics toolkit, so it has the capacity to save your files and then use that file for later on program. Okay, moving on, it's also much easier to exchange computer files than physical models. Okay, this one is a very much this one is very much great advantage of having an online simulation tool. So you don't have to worry on how you're going to share your file. You don't have to worry on how you're going to share your program or your robot. All you just need to do is simply just one click, type in the email or the code or the password if you have it. Okay. Sharing virtual robots and sample code is a great way to collaborate and stay in touch with other competitive teams long after the competitive season has finished. So, um, after the competition, it doesn't end there. So you can still share your knowledge, share your ideas, share your codes and robots to the community for later on improvement. Okay. And lastly, also, I have mentioned a while ago that is cost effective since you don't need to buy your physical robot. Okay. So if you're new to the world of robotics, simulation can serve as a cost effective introduction to learning the basics of strategy, engineering, and programming before upgrading to a physical machine. Of course, later on, if you're very much familiarized with coding and robotics, or for example, Lego Mindstorm, then maybe you can, sort of buy the physical machine. We have um, stores here in the Philippines. We have the large number one producer of Lego Mindstorm. I think it's the Felta Incorporation. So you can just buy the physical robot later on. Okay, and with the toolkit, you can build and program your robot using the exact same tools you would use on the real thing. Of course, the code right for your simulated robot will also run in real life. So it means to say that using an online simulation tool, you can also do it in an actual robotic kit. So there might be some changes, there might be some upgrades, but then the program is still the same. Okay, so no need to worry if how are you going to transfer your program. Once you save your program using the online simulation tool, once you download the program, you can just upload that program exactly the same in your physical robotic kit. Okay, so that's the number one feature of an online simulation tool using virtual robotic kit. Okay, and of course, moving on, we have here also my favorite, which is TinkerCAD, which I'm actually using for several years now. So TinkerCAD again is a free online collection of software, of course, software tools that help people think, create, and make. So TinkerCAD offers circuits, classrooms like Google Classrooms, so lessons, and also TinkerCAD has also the capability of simulating 3D designs. Okay, so not just circuit but also 3D designs. Okay, moving on. What are the things that you can do using TinkerCAD? So these are some of the things that you can actually do using TinkerCAD. First, we have here, this one is just a screen grab in TinkerCAD website. So you can just open your browser and type in www.tinkercad.com. It's free. All you just need to do is to have the, of course, stable internet connection. Okay. So again, this is just a screen grab from the TinkerCAD website. So we have the number one, design, place and wire components to create a virtual circuit or begin with a starter. So TinkerCAD offers this great feature, okay, wherein you can create your own design, your own circuit design, right? Also, we have here program. So program using code blocks or C++. So when I was a kid, when I was in high school, I dreamed of being a programmer. So it's very much, it's really good if you start with using code blocks. So this is really great opportunity for grade school students or high school students to start doing programming or coding and robotics using TinkerCAD. And it's using code blocks. This means to say it's a graphical interface programming language. We have here the C++. And the last thing is we have the simulate. See how components will respond in real life. This means to say that once you're done with your program, once you're done with your circuit, you can actually play with your design. Wherein, if you want to see the sample output, you can just simulate it. Okay, that's it. So, of course, we have here the last three features of TinkerCAD. It also offers build. Okay, take your virtual circuit and make it real. So which means to say, once you're done with your actual design using TinkerCAD, then you can just copy your design and convert it into an actual Arduino kit, an actual kit. Okay. And we have here the program. Export your source code from TinkerCAD to program your circuit. Um, Similar to virtual robotic kit, toolkit, you can save your program. It is automatically saved. You can download your program. You can share your program. You can see the different components used in your design and your program. So you can export the source code also, and you can share your program also. And enhanced, add in 3D design and printing with circuit assemblies. Again, as I mentioned a while ago, you can also use TinkerCAD in creating the actual design of your robot. So it offers you the 3D design and simulation thing. All right. So it's free. You just need to have an internet connection. Again, you cannot download the TinkerCAD thing. It's a browser-based application. Okay. So you can add 3D and printing with circuit assemblies. Okay. So now I think we are ready to proceed with our demonstration. I'll just confirm with our host for today, Ma'am Jen. Are we good to go?
Yes, carry na yan. So, we will have, Sir Dom, they would simulate with us, no? So, probably we have to provide them like a little bit of pause every now and then we'll see how they go. Ay, babantayan ko yung chat
Okay
para
po.
matitimbrehan kita. Okay?
Yes po. All
Thanks.
right. So I think if you have questions, guys, you may type in your questions in our comment section. Maybe I can give you around 30 seconds to 1 minute to type in your question so that after that we will proceed with the actual demonstration on how we're going to use TinkerCAD to simulate things to design circuits. Okay, so I'll give you 30 seconds to 1 minute.
Oo. Sir Wax, pwede mo rin, pakilagay mo rin yung link sa baba, yung ano natin, TinkerCAD website, TinkerCAD.com. Tama ba,
Yes.
Sir Dom?
Yes po, TinkerCAD.com.
TinkerCAD.com, yun po ang ating bubuksan. Okay, so Sir Wax, pwede mo rin i-post yung link sa ating live comments, please, para i-click na lang nila.
There.
Ayan, very good, yes. Thank you. Yan. Sir Dom, kailangan
Yes,
na ba nilang dyan? I-guide mo pa ba sila or dire-diretso sila ng pag-open? To sign up?
I-guide ko na lang po sila, ma'am.
Okay, good. Just open the browser, no?
Yes po.
Okay.
Ma'am Jen, let me know if we're good to go.
Yeah, sure. Yeah, pwede na, Sir Dom.
Okay, so I think I'm looking for questions here, and I think there are no questions, so maybe we can proceed with the actual demonstration on how are we going to use TinkerCAD. Okay, but before that, since I think most of you guys are not familiar with using TinkerCAD, so I can just demonstrate on how can we create our free personal account using TinkerCAD. So you can see here in my screen, I have the TinkerCAD.com. So again, all you just need to do is to open your computer, open a browser, and type in the URL address. It should be www.tinkercad.com. Again, it's www.tinkercad.com. Okay, so once you have this window in your browser, you can simply create your own personal account. Okay, you can just join now or sign in if you have your personal account already. Okay, so since I have my personal account, so I can just click sign in, and you can actually use your email or username. You can also sign in using your Google account and sign in with an Apple ID. And there is here another link. There's another link here, more sign-in options. Okay. So if you have your students, then you can sign. You can ask your students to sign in using the code from your classroom. Okay. So I'm going to sign in with a Google account. All right. So I'm using my Gmail, robotics.dominic@gmail.com. Okay. So again, TinkerCAD is free. It's not downloadable. It's a browser-based application. So this is the actual environment of TinkerCAD, the dashboard of TinkerCAD, wherein you can see in my screen that this is my profile, and you can see under my profile, it's the 3D design. Again, as mentioned a while ago, you can do 3D design using TinkerCAD, and of course, the circuits, code blocks, and the lessons. Also, you can create new project here and some of the top trending tweets from TinkerCAD.com. Okay, so what we're having right now is actually circuits. So if you have your TinkerCAD ready, so you may just click in this link, the circuits. Okay, so under circuits, you can see the different circuits which I made earlier. Okay, so you can see here your saved circuits. Okay, ayan po sila. Okay, now for us to be able to begin with a basic design using TinkerCAD, again, you just need to select the circuits and then click create new circuit. Once again, circuits and then create new circuit. Okay, so I'm going to click my create new circuit now, and then another window will open. This one is very different. Okay, as you can see in my screen, there are different components, basic components. You can also select all the components, all features of TinkerCAD. But at the moment, for the meantime, we're going to use the basic components. And then once we're ready to begin with more or complex designs, then we can also change the components from basic to all. Okay. So first, I'm going to discuss the environment of TinkerCAD. Let's familiarize the environment of TinkerCAD. So here, you have here the surprising go-go. This means to say, guys, that this one is the file name or the name of your design, the name of your document. So for us to be able to change the name of our document, we simply double-click the name, the text, and then we can delete the text. So now we can type our desired file name. So for example, this is, let's say, Felta, sorry, and TinkerCAD. There you go. So Felta-TinkerCAD. So you can choose your own file name, your desired file name for your document. Okay, and then you simply click outside the name, and then you can see now that the name will be renamed and became Felta-TinkerCAD. Okay, so part of the environment of TinkerCAD, again, this is the rotate. Okay, the rotate icon, the delete icon. Of course, we have the undo, and we have the redo if you have things to, if you have errors, so you can just redo or undo. Okay, so also here we have the code wherein here is the place wherein you type your codes, you design your code blocks. Okay, also here we have the icon for start simulation. So if you press this later on, whatever your program is, whatever your design is, once you press this start simulation, then your program will run automatically. Okay, so you will be able to see the sample output of your program. Also, we have here the export. Once you're done with your program, you can just download your program. If you're going to click this export, then you'll be able to download and save your design and program locally in your computer. Also, it has the power to share for collaboration. So you can just, if you want to share your program, your circuits, then you can simply click this icon share and type the email address or the username of your, let's say, for example, your teacher, your student, your friend. Okay. So, and some of the other parts of the TinkerCAD, we have here also the circuit view and of course the parts component list. Okay, so you don't need to worry what are the components you use. No? So you can see all the components used here, the exact name and um, quantity of the component used in your design. Okay. So of course, again, these are just the basic components in TinkerCAD. So you can select here different components. If you want to see all the components here, you can just press all. Okay, I'm just showing you the different components here. So these are all the components available in TinkerCAD. Also, we have here the basic, the Arduino, the circuit assemblies, and all. Again, so showing you the circuit assemblies. These are pre-made, ready-made circuits wherein you can just select and drag and drop in your document, and then you can simply start simulation. Okay. So, but we're not using these circuit assemblies. We'll start from zero. We'll start from scratch. Okay. So going back to the basic components here. All right. So I think that's so much for the environment, the idea of TinkerCAD. I think we're ready to demonstrate and how are we going to use TinkerCAD to create basic circuits and do programming here. So I'll give you 30 seconds to 1 minute again to ask questions if you have in your mind. And then after that, we'll begin with the actual demonstration and how can we use TinkerCAD to promote coding and robotics.
Okay, ayan. Attentive si Sir Wax, nakita niya ang mga pagkaway ko. Okay, so while waiting, Sir Dom, no, yung ating mga viewers, they can actually sign up if they have not. I know they already did
Registration.
sign up for, there was a previous lesson on this on other with other entities that they already discussed this, no? If you already have an Autodesk account, yung katulad ng senior mo kanina, they can also use that to sign in and then create another thing. I think they did one for TinkerCAD 3D and then they did one for the TinkerCAD circuit. So if you already have one and you want to learn more from us with Sir Dom, you can still use the same account. Hindi nyo po kailangang gumawa ng bagong account.
Yes, that's true.
Right? So, let's give them 2 minutes na lang natitira. Probably
Yes.
they can start. And then,
Yes.
if
I
they
think,
already have,
well,
Yes,
if you
sir.
have your TinkerCAD with you already, you can open the circuit and then, of course, look at my screen. If we have the same environment or screen right now, then you're good to go. Okay, so let's just maybe wait for the others. We have here. I'm looking at the comment section. I think wala naman pong mga katanungan. Okay, so maybe last 1 minute for you to prepare for your TinkerCAD environment, for your TinkerCAD, so that you'll be able to do whatever activity going to discuss for today's webinar.
And if they want to start na din, they can save us, no? Tama ba, Sir Dom? Kasi we would suggest if we have one demo, you save it as another file and then another demo for another file para meron kayong compilation ng inyong practice.
Yes, correct po.
Shout out kay Teacher Sai at saka kay Sir Norman. Good morning po.
Yeah. To our viewers, you may type in your questions if you have questions in mind, and we will try to answer later on. already it's time already.
Time
So
na.
I think we're good to proceed with the actual demonstration on
Okay,
how we
bye
build
ulit.
the TinkerCAD. Okay. So Ma'am Jen and Sir Wax, are we good to go?
Yes.
Yes po, yes. Go ahead, sir.
Okay. All right. Thank you po. Cheers. So we can now begin with the basic circuit design. So again, this is TinkerCAD. The blank page here is our document wherein we design our circuit. Okay. So you can see here in my right pane or right corner of my screen, these are all the basic components. Okay. So first, I'm going to teach you how the basics of coding and robotics using TinkerCAD. So I want you to look for the Arduino Uno R3. Okay, so for you to be able to use this component, you simply select the Arduino Uno R3 and double click it or simply drag and drop it. Okay, you can see here in my screen I have the Arduino Uno R3. Okay, so again, you can change the name of your component. So you simply select your component, and then you can see here there's a pop-up small screen in my window. It says here name. So you can type your desired name, let's say Arduino. Okay. And then to deactivate that, you simply click anywhere in your screen. Okay. And of course, we have here the actual board, the actual Arduino Uno R3 board. So I'll just zoom it. Okay, so I'll discuss the basic parts of the Arduino Uno R3. You can see this one is, if you have the physical Arduino kit with you, it's similar. It's very similar. Okay, so you have here the first part. We have here the analog in. This means to say that these are your analog pins wherein you can insert or plug in your analog components, your analog sensors, and other components. Okay. We also have here the power pins. We have the VIN, okay, the GND. We have here two GNDs, which means to say that these are the ground or the negative. We have the 5 volts here, the 3.3, the reset, and the IO ref. Okay, so these are just some of the basic parts of Arduino. Also, we have here the digital pins here from 0 to 13. Okay, you can see in my screen. So these are the digital pins. If you have the digital components later on, then you can just plug in your digital components. Okay. And also, of course, we have the USB jack here, or the cable, the download cable, wherein if you want to download your program later on, all you just need to do is to plug in the download cable, and then you're good to go. And of course, we have the jack here. This one is the power jack wherein you can plug in a direct current. Okay. So yeah. Also, we have here the reset button, the small, the red color thing here. This one is the reset button. If you want to reset your program, then you just simply press the reset button. Okay. So so much for the Arduino Uno. Okay. So Arduino is very much capable of doing big things, great ideas, innovative ideas also. Okay. So right now I'm using Arduino as the main microcontroller board for our CNET application. Okay. So you can buy this Arduino Toolkit. I think in Felta they have it. Okay. So moving on, let's add a new component, which is the breadboard. So you simply select the breadboard and drop in your document. Okay. So here we have the breadboard. If you're new with circuits, again, breadboard is very much effective in prototyping designs. Okay, so you can see here my breadboard, it has letters here and also numbers. Okay, so you can see if I mouse over, you can see the connections between pins. Okay, so you can see from A to E it's connected. Okay, so this is how you read a breadboard. Also here the power bus or the power pins here, the negative. So you can see here that once I select the first pin, everything will be affected. Everything will be selected. That means to say that these pins are connected to each other. So which means if I'm going to plug in a component or a power in my negative, in my first pin under negative, then everything will be affected. Okay? Also here we have the positive here. So yeah, so that's how you read a breadboard. or how you use a breadboard. Now, let's add another component, which is the resistor. In physics, resistor is used to, simply resist or simply control the flow of the electricity or the voltage. Okay, to limit or to yeah, to avoid direct, what do you call this one, the direct flow of electricity, so para maiwasan yung pagkasira ng mga components natin later on. So it's very much important to use correct and proper resistor value. Again, you can see here my resistor. It has two legs, terminal 2 and terminal 1. But a resistor has no polarity, which means to say that it has no positive or negative. All right? So it has no polarity. Okay? So which means to say kahit po magkabaliktad yan, it will still work. Okay? So that's for the resistor. Okay? So but guys, there are different values for our resistor. So careful on using also resistors. And the next thing to do is select the LED here. I have here the red LED. Now you have the power to rename and change the color of your LED. Here you can see the color here and also the name. For example, we can change this to, let's say, green LED. Okay, and then the color, let's change it to green, of course. All right, so you can see if you change the color, it will automatically change also in the actual circuit design. Okay, so it's already green now. And you can see here, I have two legs for my LED. We have the cathode and anode, which means to say we have the positive and negative. The cathode is the negative, and the the anode is the positive. Okay, so careful on using LED also. Okay, so our first activity for this morning is actually designing simple circuit wherein it will turn on an LED. Okay, designing a simple circuit on how to turn on an LED. Okay, now going back to our main circuit design, for us to be able to plug in different components to our breadboard, all we need to do is to simply select the component. So I'm selecting my resistor right now, and then you simply move and drop to your desired position in your breadboard. So for the meantime, I'm going to put my resistor here on my breadboard, E6 to G7. Okay, so again, it's connected E6 to G6. So which means to say that here in the group of A to E and F to J, they are actually connected to each other already using the resistor. Okay, so it's connected again. I connected my resistor, put it in E6 to G6. Okay, and the next thing to do is to select your LED, and of course, move it here, and let's first rotate our LED. Okay, rotate our LED. You simply select your LED, and then you can see in my upper right corner of my screen, I have here the rotate icon. Okay, select the component that you want to rotate, and then you click the rotate icon here. You can see now my LED. Okay, so yeah, so we can now put our LED here in our breadboard. So we want that our negative leg will be in our negative value, a negative breadboard. Okay, do this way. And you can see now it's connected to our negative. And for our positive leg, we need to connect this one in our breadboard. So let's try to put to put here in our A6. You simply click the leg and then click to whatever position you want to put your LED. Okay, so you can see now it's connected already. Okay, yep. So the next thing to do is, of course, we need a negative power. Okay, so simply click here. Okay, and then so select here the GND. So GND means negative. All right. So GND means negative. Okay, do not forget that. Okay. So which means to say that our LED has the power source already from our negative value of our microcontroller board, which is the Arduino. Okay, so yep. And the last thing to do here is we need to get a positive power from our digital pin. Okay, so kailangan po natin kumuha ng positive sa ating digital pin. So all we need to do is to simply mag-select po tayo ng kahit anong pin dito. Pwede pong J6, I6, H6. So kahit alin po dyan po pwede po. Just make sure na nasa isang ano po sila? Nasa isang column po sila. Okay? Nasa iisang column. So basta nasa 6 po sila, okay lang po yan. Let's say H. Kuha po tayo sa H. Click po natin yung H and then i-draw na po natin yung line papunta sa ating pin 13. Alright? So, nasa pin 13 po siya. Okay? So, it's your choice po kung gusto niyo gumamit ng other digital pins. But for the meantime, I want you to use digital pin 13. Okay? So, you can see now that my LED is connected to my Arduino, the negative pin, and the digital pin here. Of course, as a good programmer and as a good circuit designer, we must change the color of our wires. So if it's negative wire, then it should be black. So you can simply select your wire and then change the color of your wire. Color here and then change it to make it black. And here, the green LED, just leave it there. Just green na lang po siya for the meantime. Since the color of our LED is green naman. Okay? So now we're good to go. We're good to program our LED or our circuit. So how are we going to program our circuit is to simply pindutin lang po natin yung code. Okay? Ito po, code. Okay? So pag pinindot po natin yan, lalabas po yung feature na pwede na tayong mag-program. Okay? So now pipindutin natin yung code. You can see here, meron pong lumabas na pop-up. Ito yung blocks po. So you can see sa right part, meron siyang program na dati. So ito ay pre-program, standard program, which means to say po na kapag gumawa po tayo ng circuit or ng design sa TinkerCAD, agad-agad po nating makikita to. Common to sa lahat ng circuit natin using TinkerCAD only. Okay? So, which means to say, since ginamit natin yung digital pin 13, automatic po nagagana na ang ating LED kasi meron pong standard or default na program na nakalagay na mismo sa TinkerCAD. So, ang gagawin po natin muna for the meantime is to simulate yung ating circuit. So, isasimulate po natin. Zoom ko lang ng konti. Ayan, para makita nyo yung output. And ipapress ko na po itong start simulation. Now, you can see my LED is turning on and off. So, meron siyang interval na 1 second. Okay? Ayan. So, hintayin po natin yung iba para sa ganun makahabol po sila, no? So, you can see, again, yung LED po natin nagbe-blink na po siya. And ang interval po niya ay 1 second po. Ayan. So, I think okay na po, no? Now, stop simulation po natin for us to be able to edit our program. Stop simulation muna natin. And hindi ko po ituturo sa inyo how to use blocks. Okay? Hindi po tayo gagamit ng blocks. So, ang ituturo ko sa inyo is how to program using the text-based. Bakit nga ba text-based? Text-based po siya kasi mas mahirap siya ng konti na aralin compared sa blocks. Kasi si blocks, makikita nyo po kagad na nandiyan ang instruction. So, drag and drop nyo lang po siya. So, proceed po tayo sa text. Okay? So, again, press po natin yung code. Select po natin yung blocks. Meron po kayong choices here, blocks and text, and text. So, pipiliin po natin, guys, ay yung text. Okay? Text po, select po natin yung text. And then, kapag may lumabas, are you sure? Yes, I'm sure. Press lang po natin yung continue. Okay? So, now, kakaiba yung lumabas sa aking screen. Code na po siya. So, text-based code na po. Ayan. So, 30 seconds po muna. I-check lang po natin yung ating comment section bago tayo mag-proceed. So, meron po tayong questions. I think, Ma'am Jen, meron po tayong katanungan from Sir Ronald Constantino.
Ayan. Wax, where am I? Kita na ba ako? Okay, so may mga questions dito. Sabi ni Sir Ronald, Sir, is Arduino capable in robots for factory or only for prototyping?
Yes. So
Depende, no?
thank you, Sir Ronald. I think Sir Ronald is from Lasam, Cagayan. So Sir Ronald, Arduino is capable of um, designing a prototype circuit or designing a prototype project, and also at the same time designing a factory or sophisticated
Industrial.
product, no? So pwede po siyang gamitin, so both prototype and yung pang factory or pang ano bang proper term
Industrial.
dun, pang business, industrial. Yes, ma'am Jen, tama po ba?
Yes, pwede. Kaya lang, of course, hindi naman kaya yun ng isang board. Pero for most factories, mas complicated yung kanilang ginagamit, no? So, hindi na siya ganyan. Normally, they would manufacture or they would buy off from others. Pero, if you are an engineer and you have a project within the industry, like ako dati, I worked for a stainless steel company. So, yung aming R&D also uses 3D design and then ilo-load sa program. Iba naman yung mga sophisticated na, no? Pero ito, if we provide these to the students, they can simulate how an actual engineer decides in an industrial firm. Yun yung advantage naman ito.
Yes,
Yeah.
tama po yun. Ayan. So, ayun yung tanong po ni Sir Ronald Constantino. Okay, so I think na-answer po natin yung tanong ni Sir Ronald and proceed na po tayo. So, guys, you can see in my screen, meron po tayong yung circuit design and then yung code natin. Again, ito po yung default na code, excuse me, which means to say na hindi natin tinype to. So, but what we need to do now is to edit our code. Okay? So, i-zoom ko lang po to, no? Kasi I think in our monitor, medyo maliit po siya tignan. So, i-zoom ko lang yung ating code. Ayan. So you can see po na merong dalawang parts ang ating TinkerCAD program or ang ating Arduino program. So, unang part po ng ating program, we have the void setup and also we have the void loop. Under void setup po, ang ibig sabihin po ng void setup, ginagamit po itong void setup kapag gusto po nating integrate or gusto nating initialize or ilagay yung mga components, yung mga variables, i-declare lahat ng data types or kahit anong components natin, nilalagay po natin siya sa loob ng void setup. Careful po tayo, no? Kapag sinabi natin sa loob ng void setup, it should be in between the two curly brackets. Ito po, two curly brackets. Ayan, dapat nasa loob po siya ng dalawang curly brackets natin. Okay? And also, kapag may nilagay po tayong program or code sa loob ng void setup, yung program na nilagay natin, tatakbo lang siya ng isang beses. Okay, void setup, once lang niyang iraran. Okay? Well, unlike void loop, meron po yung term na loop, which means to say, kapag meron po tayong nilagay na program inside our void loop, ang mangyayari po nun, mag-run po yung program natin continuously. Tuloy-tuloy po yun as long as our Arduino kit or our Arduino board is connected to a power source. Habang may power po ang Arduino natin, naka-on lang po yun, gagana at gagana po yung program na nasa loob ng void loop natin. Okay? Yun po yung pagkakaiba ng void loop and then void setup. Okay? So, here, sa first po natin na code, pin mode, 13 comma output, ang ibig sabihin po ng first line na to, chers or guys, ay ito yung declaration na ginamit natin. Remember, ginamit natin yung LED. Tama? So, pakita po natin yung ating design, no? Yung LED po natin na green ay nakakonect po sa ating pin 13. Okay? Again, yung ating LED na green, nakakonect po siya sa ating digital pin 13. Kaya po, meron tayong digital pin 13 dito. But, remember, na itong program na to ay default. Which means to say po, na kapag hindi natin ginamit ang ating pin 13, ang ginamit po natin, let's say, ay pin 12, 11, 10, 9, 8, kailangan pong palitan natin yung 13 na to and make it the correct pin. So let's say 12 ang ginamit natin, then should be 12 also. Okay? Pin mode means you declare the pin number, the pin assignment. Output means it's an output component. Pag sinabi natin output component, this means to say that yung component na yun ay nag-emit or nag-produce ng like sounds, like lights, or kahit ano po. Output po siya. Okay? Kapag sinabi naman natin input component or input sensor. Ang ginagawa po nito ay nag-extract, nag-accept, kumukuha ng values from the surrounding, from the environment. So output and input component. I'm pretty sure alam niyo po yung ibig sabihin ng output and input component. Okay? So that's why it's output kasi LED nag-emit ng light. Okay. Now, proceed po tayo dito sa part ng void loop. Cheers and my dear viewers, careful po tayo dito. It's case sensitive. Kapag sinabi natin case sensitive, small letter is different to capital letters, to uppercase letters. Okay? Small and upper are two different things sa programming. Okay? So, kailangan po, it's capital letter M. Here, it should be always capital letter M. Also, you can see it's output po natin dito ay sobrang capital lahat. Then, it should be capital letters also. And then, we have here the semicolon. Okay? This means to say that this line is a statement. Okay? Proceed po tayo sa void loop. I-zoom lang po natin ng konti. Under void loop, we have the digital write 13 high. The first two codes here, digital write 13 high, delay 1,000. So makikita niyo po dito, no? When we say digital write 13 high, ang ibig pong sabihin nito, my dear participants, is we are actually commanding our computer or commanding our board to turn on whatever is the component inserted in our digital pin 13. Hindi lang po LED to hindi lang po LED ang usapan natin dito. Ano man yung component na nakalagay sa pin 13, i-on po niya yon. Ang ibig sabihin po ng high is 1. Ang ibig sabihin po ng 1 is on. High, 1, on. Digital write, bakit digital write? Kasi it's a digital component. Nakalagay po siya sa digital pin. Kung wala po siya sa digital pin, nasa analog pin, kanina pinakita natin, it should be analog write. Okay? So I hope na-explain ko mabuti yan. Again, it's case-sensitive W ang capital natin. Then it should always be capital letters. Okay? Now we have also here the delay 1,000. Again, nakalagay po dyan, wait for 1,000 milliseconds. Ibig sabihin po na ng katumbas po nun is 1 second po. Okay? Isang segundo po siyang mag-on. Of course, kapag nag-on siya, mag-off din yung ating LED because we have here the codes for our how to turn off the LED. So ang kabaliktaran po ng high is low. Not slow, but low. Low po. So ibig sabihin, after ng isang segundo, mag-off po automatic yung ating LED kasi meron tayong code na digital write 13 low. Again, yung 13 natin, ayun yung LED. Delay means mag-on or off siya in a specific span of time. Okay? So ngayon, ibig sabihin po nun, guys, kapag tinanggal ko ang isa, kapag tatanggalin ko to, at in-start simulation ko, ano kayang possible na mangyayari sa ating program? Okay? So, yung sa mga nakaka-follow po ngayon, no, pwede niyo pong tanggalin din yan, no? So, i-zoom ko ulit yung ating circuit. And, tinanggal po natin yung digital write low, start simulation ko po, para makita niyo po ang kalalabasan ng ating output. Ayan. So, you can see now my screen. Excuse me. Yung LED po natin, naka-on lang siya. Standby. Naka-on lang. Bakit nangyari po yun? Nangyari po yun kasi tinanggal po natin yung digital write 13 low. Tinanggal po natin yung function na mag-off yung ating LED. Okay? So, napakasimple pong gamitin tong code na to, itong program na to. Okay? So, stop simulation po natin. Now, let's say for example, tapos ka na sa program mo, tapos ka na sa circuit mo. Question is, pwede ko bang ibahin yung color ng LED? Yes, the answer is yes. Pwede pa rin natin ibahin yung color ng LED. So, balik lang po na tayo sa circuit. Para po ma-edit natin yung circuit natin, i-press po natin tong code. And then you can see, zoom lang po natin ng konti. I-press po natin yung LED and you can change the color. Kung gusto po natin ng blue, why not? And then of course, palitan po natin ng blue LED. Para naman sa ganun, parehas po sila. Okay? So again, you can see nag-change na yung color, pero no need to change the code. Okay? Start simulation po natin. Ayan, you can see na naka-on na po yung ating LED. Ayan po siya. Okay? So I think so much for the LED. Stop simulation po na natin. Now, magdadagdag po tayo ng LED. Gagawin po natin 3 LED. Medyo magiging complex na po ng konti yung ating code. Okay? So, Control-G ko lang to para lumabas yung ating nagawang code kanina, yung 13 high and low. Ayan. So, bibigyan ko kayo ng 1 minuto para mag-ask ng katanungan po. And then we proceed with more complex circuit and program. Okay? I think, Ma'am Jen, magbibigay muna tayo ng kahit 1 minuto po.
Yes, babasa tuloy ako ng kaparasong comment. Okay, Sir Dom from Sir Orlando, nagamit niya na daw yung Arduino Uno 9 years ago. Talaga pong thunders na po itong Arduino, no? Ngayon lang siya masyadong nabibigyan pansin kasi nga boom yung robotics, and Arduino kits are one of the cheaper options but very powerful devices, ano? And thank you kay comment ni Sir Ronald. Very good daw tayong ako daksali, hindi pala. Very good ang speaker and very detailed. And then, thank you, Sir Dom. May notes ako dito kasi nga nagno-notes ako. Maganda talaga na mag-practice muna tayo sa hard code. Kasi actually, when you put the devices in TinkerCAD, ginagawa niya na talaga yung black code. So, what's the point of using the black code kung nandun naman? And then, we can explore doon sa ating hard code. In real life, when these are advisable for senior high school, grades 10, 11, 12, 9, 10, 11, 12 talaga yung mag-start na ng coding. Dapat nga mas maaga, kaya lang dahil bago pa rin. Paano daw ibalik yung na-delete na text code?
Ayan. So, paano po ibalik yung na-delete na code? Nag-comment po ako po yung RoboGuro. Meron po akong YouTube channel din. You simply press in your keyboard the Control-Z. So, babalik po yun. But make sure na naka-stop simulation po kayo, no? Para bumalik yung code.
Sabi ni Sir Dom, tayo magdadagdag ng LED, no? So, habang nagtatanungan tayo dito, I challenge everyone to start placing the peripherals para pamaya pag ginawa ni Sir Dom, makikita nyo, tama ba yung understanding ko nung pag-connect. And then, very important talaga, Sir Dom, yung assigning variables. Very good yung ating output is the result, input is the calling. Kasi kailangan nating i-call yung ating mga variables if we do not assign. When I'm teaching, I normally tell the kids we have to color code. So when we use the green LED kanina, we use the green wires. Tama, Sir Dom? No. When we use blue LEDs, I tell them use blue wires. So pag sinabi ko, everyone, let's change the blue LED. Hindi na kami magtatanong, ma'am, blue? Yung mga bata ganyan, kahit matanda na, pag sinabi mo blue, sabihin pa nila, ma'am, blue, hindi, orange. So, kailangan, para mabilis din tayo as teachers magturo, we assign color codes para mas madali yung ating pag-i-instruct. Diba, Sir Dom?
Yes po, ma'am, Jen, tama po yan. It's very important to use proper naming conventions, proper wiring codes. And then, gaya po ng sabi natin, for example, kapag madami na po kayong design, madami na kayong circuits or components na nasa inyong design, hindi na po kayo malilito kung ano ba tong, para saan tong wire na to, para saan tong black na wire na to. Always remember, kapag sinabi nating black wire, i-assign nyo po ang black wire para sa negative na value, para sa negative na power. And ang red naman po ay para sa positive na power. Always pong remember yan. Okay? Always po remember yung proper wiring code natin. Napaka-importante po yun. Okay?
Tsaka yung orange wires. Tsaka red, yun ang re-reserve yan. Sakit kasi, konti lang. Pag di maiwasan, gumamit ng ano yung tawag dun, sir, yung paper na tape, masking tape. Tapos lalagyan mo ng mga R1 or E1. Kung walang-wala.
Yes. Kung wala naman po kayong, let's say, naubusan kayo ng wires, then, good choice po na gumamit ng mga, yung tape, tama si Ma'am Jen, no? Para lagyan ng label kung ano ba yung tape, ano ba yung wire na yon, para hindi po rin kayo malito. Okay? Ayan.
Kung anong pin yung nilagay.
Wala na atang mga katanungan, no? So, to go na po, we're good to go. So, I hope, cheers and my dear participants, sinusundan nyo po yung ating design, no? I think meron pong sumusunod kanina. Ayan. So now, gagawa po tayo ng multiple LEDs. So ito, lagi ko pong sinasabi, challenge yung mga students ko and other participants na dinedesign ko po yung aking lesson in such a way na mag-iisip po yung participants ko, how can they connect Arduino, innovative design, in real life. So let's imagine po na ang problem ng ating community, ng Pilipinas nowadays, Of course, number one ngayon ay yung pandemic, which is the COVID. But kapag bumalik po sa normal, ano po yung usually problem na na-encounter natin? Of course, hindi natin mawawala sa Metro Manila or kahit saang lugar sa Pilipinas na city, yung traffic. Right? So merong traffic. So ngayon, i-integrate natin yung traffic into an Arduino design. When we say traffic or traffic system, meron pong different lights. We have the green, we have the orange, and we have also the red. Yung bawat color po doon, nagbibigay siya ng signal na, for example, green is go, orange is to prepare or to move faster, and red to stop. So gagamit po tayo ng ganung idea. So magde-design tayo ng circuit na we think is much helpful than our current traffic light system. Okay? We think, kunyari lang naman. So gagamit tayo ng iba't iba pang colors ng LED. Now, going back sa ating design, kapag nawala po yung ating circuit or yung ating mga components sa right, meron po kayong makikitang arrow facing left. So, click nyo lang po yan and then babalik na po kaagad yung ating mga components. Okay? So now, magdadagdag na lang po tayo ng components dito. So, for us to be able that, start po natin sa pagdagdag ng resistor. Okay? So, click po natin yung resistor, i-drop lang po natin dito. Kahit saan po dyan sa breadboard natin. As long as make sure na nasa isang column po lahat sila mamaya. Okay? So, let's say gamitin po natin yung 12. It's E to G12. And another component, same resistor, click resistor here, i-drop po natin siya sa, let's say, 18. E18 to G18. Ayan po. Meron po tayong tatlong resistor. Of course, kailangan din natin ng LED. Click po natin yung red LED, drop natin dito, and another LED, i-drop po natin dito. Okay? So, kanina, gaya ng sabi ko, pwede natin palitan yung color. So, palitan natin to. Gawin natin, let's say, orange. Orange LED. So, palitan din natin to ng orange. Sorry. Ayan. And of course, ito, red na po to. So, gawin po natin red LED. Ayan. So, meron na po tayong tatlong LED. Of course, itong blue, gawin po natin siyang green. Okay? And then, green. Ayan. So, green, orange, and red. Okay? Green, orange, and red. So, ready na po tayong i-reposition ng ating mga LEDs. Again, para ma-rotate po natin sila, select po natin ang component na yun. And then, nasa upper left corner natin yung rotate. Click lang po natin ng multiple times. And heto na po siya. And then drop po natin ngayon to sa ating breadboard. Make sure lang po nasa isang column po sila ng ating resistor. So select and then drop. I think nasa 12. You can see in my screen. Also, meron yung anode and then simply click po natin yung positive wire na yun. And then drop po natin siya sa A12. Ayan po siya. Of course, palitan po natin yung green. Gawin po natin orange. Ayan. And yung isa pa po, yung red, select and then rotate. Multiple times. And zoom and drop po natin dito sa 18. Ayan po siya. And then of course, select po natin yung pin na yon. And then change. Gawin po natin siyang red also. And there you go. Ayan po. So pwede na natin i-connect lahat ng LEDs natin sa ating digital pins. Now, wala po tayong naka-assign kaagad na pin. Ang gagawin po natin, it's your choice if you want to assign those LEDs to different pins. It's up to you po. So for the meantime, para po mas maayos yung circuit design natin, gagamit po tayo ng LED ng digital pin na mas malapit sa 13. So una yung ating orange. Select po natin yung orange. And then drop ko na po siya sa ating digital pin 12. Ayan, para po mas maayos tignan. Importante rin po na malinis at maayos tignan ang ating design. So again, palitan po natin ito ng orange. Ayan. Medyo OC po ako kasi sa design. Ayan, so kailangan po talaga maayos. And then of course, we have the red LED here. Click po natin siya. And then ilagay na lang po natin sa pin, digital pin 12 and make it red also. Ayan, so color code, proper color code, gaya ng sabi ni Ma'am Jen kanina. Ayan po. So I think complete na po yung ating circuit design. Meron tayong red, meron tayong orange, meron tayong green. Also connected na po lahat ng ating digital pins. But question is, do we need extra wire for our negative. Mapapansin niyo po kanina, nung nilagay natin tong green, naglagay tayo ng negative. Kailangan pa ba natin ng isa pang wire dito or isa pang wire dito para i-connect sa ating negative pin? Sa palagay niyo po, Ma'am Jen, kailangan pa ba natin? Nandiyan pa ba si Ma'am Jen? Check lang po natin, no?
Ayun. Kasi kaya pakaway na kaway mo. Okay, so of course, Sir Dom, based on, yun yung, kaya importante talaga as teachers, marami tayong kasamang teachers, we need to inform our students of the parts of the breadboard. Kasi kapag hindi natin na-discuss yan, ang gagawin, lalo na kung ang binili nating materials is yung nakarolyo na wire, ang gagawin ng mga bata, puputol-putol-putol sila ng putol. So, nagsasayang ng material. If they know basic principle ng circuitry, ng mismong breadboard, then they will be able to, maximize the use of the board. Yun yung maganda dyan.
Tama po yun. Ayan. So, cheers, to answer yung ating tanong kanina, kung kailangan pa ba natin ng extra na wire, the answer is, obviously, hindi na po natin kailangan ng extra na wire. Tama ba dyan, no? Ayan. So, yes. No need na po. Kasi meron na po tayong wire connected to our GND. Ayan na po. Again, gaya ng sabi ko kanina, once na naglagay tayo ng wire dito, everything will be affected as you can see in my screen. May green po, no? Ayan. So, lahat po affected na. So, ang kailangan na lang po natin ay idagdag yung ating code. Okay? So, balik po tayo sa code natin. Press po natin yung code. Ito po yung code natin kanina. Of course, gumamit po tayo ng extra na wires and extra na LEDs. So, kailangan po natin i-declare lahat ng ginamit natin na LEDs or na pin. So, we have here the pin mode 13. We simply copy-paste this. Medyo sinisipag po tayo. Copy-paste lang po natin para mag-paste po tayo. Ayan. So, meron na tayong tatlong declaration here. Ang ginamit po natin ay 12 and 11. For the meantime, hindi ko muna ituturing variable. Ilalabel po lang natin to using yung ating comment, / sign, and then ilagay po natin kung ano ba itong 13 na to. This one is the green LED. Napaka-importante po. Okay? And then this one, yung 12 natin is the orange. Sorry. Ito po yung orange natin na LED. And of course, yung last one is the red LED. Importante po na merong comment para sa ganun mag-guide yung ating users later on. Okay? Ayan, so tama po yan. The next thing to do, we want...
Wait lang, yes, baka magulo sila. Kasi sabi natin kanina sa kanila ay ilagay mo kahit saan mo gusto. Tapos hindi nyo naman ginaya yung sa amin ni Sir Dom. Baka mag-expect ka na magsa-simulate. So kung ano yung pin na ginamit mo.
Correct.
Yun that's ang correct. Gagamitin mo.
Opo. Tama po yun, no? Gaya ng sabi natin, kahit saan nyo po ilalagay, pero sabi natin kanina, kung ano yung assignment, kung ano yung pin na ginamit natin, dapat yun din po yung nasa program. Kung ang ginamit nyo ay 2, 5, or 7, dapat yun po yung nakalagay sa ating declaration, which is yung pin mode natin. Napaka-importante po yun. Okay? So since na-declare na natin yung tatlong LEDs natin, pupunta na po tayo sa code natin under void loop. Meron tayong digital 13 high. So pwede natin ilalagay po muna natin yung 12. So how to do that? Digital. Na-type po natin digital. Ito muna. Digital right. And then yung pin-assignment which is 12. I-high muna natin siya. And then semicolon. And then we have also the delay 1,000. Semicolon. Of course, gaya ng sabi natin kanina, para mas mabilis po tayo sa discussion, i-copy-paste na lang po natin to. I-paste it here. And then, palitan po natin yung high and make it low. Now, para ma-sure po natin na hindi tayo malilito kapag mahaba na, maglagay tayo ng comment dito. Sabihin natin, this code is for orange LED. Ayan. And this one is for green LED. Ayan po siya. And the last thing, copy-paste po natin to. And change po natin tong orange, make it red. Yung 12 po gawin nating 11 and 11 also here. Ayan. So meron na tayong 13, 12, and 11. Now, kapag iraran po natin to, kapag isimulate natin, yung arrangement po ng ating code is nauna ang green, followed by orange, and then last yung red. Ang mangyayari po nito, automatic po, kung ano yung nauna sa code, yun din ang mauna sa ating design. So mauna ang green na mag-on, orange, and then red. Okay? To show you, i-close ko muna tong code, and then start po natin yung simulation. Hindi po natin start simulation. Ayan, so green, off, orange, off, red, off, back to green. And naka-loop po yan, tuloy-tuloy. Remember, nasa loob po yan ng void loop. So, yan po siya. Ayan po. So, nakikita niyo po yung output natin. Green, orange, and red. Kung ano po yung arrangement ng ating code, ganun din po mangyari sa ating mismong design. Ngayon, kahit po pag iba-ibahin natin, yung ating assignment dito, halimbawa po, no, etong green, nandito sa dulo. Tanggalin po natin to. I-rearrange natin, no? Lagay natin dito. Of course, ito, no? Ilagay natin dito. And then yung wire natin, ilagay natin doon sa dulo. Sorry. Ayan. Kahit ilagay po natin dyan. Yung code po natin ang masusunod. Sabihin po natin, no, ito na orange na nauna, then green, and then red, and then green. Hindi po mauuna ang orange. Mauuna pa rin po yung green. Kasi sa ating code, nauna po yung ating green. Yan po yung arrangement. So kung i-run po natin, makikita niyo po dito na mauna pa rin mag-on yung ating green. Ayan po na-notice po ninyo. Green pa rin ang mauuna.
Yun, tama. So, one more thing, baka minsan may problema sila. No, bakit ayaw mag-simulate? Kasi minsan nakalimutan mo ilagay yung semicolon.
Opo.
Hindi mo na-close yung line. So, importante yung importante. Or, naglagay ka ng comment, walang double slash. Bakit ba may double slash, Sir Dom? Para saan ba yung double slash
Para saan
niya?
nga ba yung double slash? Yung double slash po mapapansin, nag-change ng color. Ang double slash po, reserve po siya as function for a comment. Pag sinabi pong comment, guide. So, ibig sabihin po nito, it will not affect your program. But, mag-affect po siya sa mismong user, sa mismong tao. Not in the program, but it will affect how the user will read your program. So, halimbawa, wala po ito. Hindi natin nilabel na yan. So, pag binasa ko, digital writer din high, ano kaya para saan kaya itong code na to? Mag-iisip ako, para saan itong code na to? But, kapag meron tayong comment, alam ko kaagad kung para saan yan. Tama po? Sorry. Alam ko kaagad
At kung
para
ikaw
saan
ang
itong code na to. Yun yung Q, yun yung
At ikaw ang teacher, ikaw ang Q. Tama.
Yes po. Ayan. Alright. So, I think okay na po tayo sa LED. Kung meron po tayong mga questions, Ma'am Jen, 1 minute po ulit tayo, no? And then proceed na po tayo sa next na goal natin, which is yung how to print in our TinkerCAD. Kasi pwede po kayo mag-display ng text dito sa TinkerCAD. Okay?
Yes.
Okay, 1 minute po muna tayo
So
para sa
far,
mga katutuhan.
wala silang question. Meron silang comment. Thank you for this very informative webinar. Very good. We are trying our best po and give you very specific details kasi this is a very technical lesson. Ano? So, maliit na bagay na mabilis ma-frustrate yung mga bata. Kaya kailangan maliliit na bagay ay ating dadaanan. Right? Marami bang natatantrum sa klase mo, Sir Dom, pag mga ganyang bagay?
Yes, ma'am.
Marami bang mga students din na nagtatantrums dahil hindi
Yes,
gumagana ang simulation?
Well, actually, in our school, nag-start po kami ng coding and robotics using Arduino 2018. Nag-purchase kami ng 300 kits for senior high school, grade 12. 300 kits starting. And then, on my second year in that school, nag-purchase na po kami ng 1:1 kit for grade 11 and 12. So, nag-purchase sila ng around 600 kits. Individual po kasi nakita nila yung kahalagahan ng coding and robotics sa mga bata and in real life. Kasi ang future natin talaga robotics, hindi tayo pabaliktad. Pasulong po tayo. Papunta po tayo dun sa robotics era. So, ayun po, sobrang powerful po no effect ng mismong TinkerCAD. Nag-start din po ako sa TinkerCAD. In-explain ko sila how can we use TinkerCAD. And then, bumili na po kami ng actual na kit. Ayan.
Yan, may tanong si Sir Norman. Hi, Sir Norms. Hello, Sir Dom. Is there any difference if the resistor is connected in the cathode junction of the LED instead of the anode? Parang
Okay.
nadaanan mo yung kanina, no?
Ayan. Ma'am Jen, based on your experience, meron po bang pagkakaiba ang positive and negative sa pag-connect sa ating resistor?
Okay, so far wala. Pagka meron, parang tatakbo ako, no? Parang something is wrong. So, wala po. Pero, kapag yung LED ang nagkaroon ng issues, malaking issue yon. Kasi nga, very important yan sa mga setups. We normally use LED as indicator. So, hindi siya mag-function kung baligtad.
Tama po. Now, to address yung question po ni Sir Norman, Sir Norman, kahit alin po doon ang gamitin natin, kahit po sa cathode or anode, wala po siyang effect since ang ating resistor ay tawag doon. Well, it's based on my experience po, no? Ang ating resistor po ay walang polarity. Naglilimit lang po siya ng flow ng current. So, kahit po alin sa dalawa, cathode or anode, okay lang po. But in more complex circuit design, sa mga electronics po, I think meron pong pagkakaiba ang paglagay natin ng resistor sa cathode or anode ng LED. I'm pretty much sure na meron po 'yan. May effect po 'yan sa mga electronics engineer po natin kasi hindi naman po electronics engineer, I'm a information technology teacher. So yun po yung pagkakaalam ko so far.
Tsaka sir, depende sa size, no? Kung syempre pag habang lumalaki yung resistance, humihina yung LED kasi nga nire-resist niya yung power, no? Kaya depende kung anong requirement. So before we teach, tapos kailangan familiar tayo anong klaseng LED ba yung nilagay mo, anong size na resistor ba yung nilagay mo. Yun yung nakaka-affect actually, not the polarity. In the first place, wala naman.
Ayan. So, sir, paano po gagawin hindi ma-copy-paste ang code? Ma'am Gemma, I think naka-simulate po kayo. All you need to do is to stop simulation. Click niyo po yung stop simulation. Naka-green po yan sa upper right corner. And then there you go. Pwede mo na pong i-copy-paste ang code. Select mo yung code na gusto mong i-copy and then paste mo lang po siya kung saang location.
Okay. I think okay na sila. Ano ba yung susunod natin, Sir Dom?
Ayan. So ang next po natin is how can we display text in our Arduino's design or sa ating TinkerCAD. Magdi-display lang po tayo ng text and after that, magpro-proceed po tayo on how we're going to use button and buzzer. Ayan po. So ayan. So papakita ko na po sa inyo kung paano gumamit ng display text in Arduino or in TinkerCAD. Ma'am Gemma, kailangan niyo pong i-press yung stop simulation sa upper right corner. Naka-start simulate po kayo kaya hindi niyo po nakaka-copy paste. So kailangan naka-stop simulation po. Okay? So proceed na po ako, Ma'am Jen, no? So ang gagawin ko naman po ay paano ako magdi-display ng text. Okay? So magdadagdag po tayo ng isa pang component or code. Sorry. Here, under po ng void setup natin, lang natin ng konti, i-type po natin ang serial.begin. And then, yung value na 9,600. Sorry. Ayan. So, ano nga ba itong ibig sabihin ng serial.begin? Ang ibig sabihin po ng serial.begin 9,600, ito po yung baud rate. Pag sinabing baud rate, ito po yung connection between our computer and the actual Arduino kit. Okay? Ito po yung connection nila. Ito yung bridge, kumbaga ganun. Yung 9,600, yan po yung default na value na ginagamit. Marami pong iba't ibang value depending on the board. Depending on how we wanted to use yung specific command, specific component. So marami po. Pero the default is 9,600. So ito ay library para sa ganun or function para sa ganun. Matawag natin yung how can we display text later on. Okay? So serial.begin 9,600. And sa loob po ng ating void loop, gusto po nating i-display or ipakita sa ating screen na kapag umilaw ang green, ipapakita din natin yung text na green LED is on. Okay? So gagawin po natin yan. So we just need to type serial dot print ln and then green LED is on. Ayan. Ang ibig sabihin po niyan, kapag mag-on na po yung green natin, i-display po niya yung text na green LED is on. Okay? So dadagdagan lang po natin ng konting delay. Pag sinabi nating delay, ito po yung in time interval, gawin natin yung 2 segundo yung pag-on. At kapag nag-on, mag-display yung green LED is on. Copy-paste po natin to. Here, green LED is off naman po dito. Ayan po siya. So dinagdag po natin 2 codes, no? Serial.println green LED is on. Serial.println green LED is off. Okay? So ayan po. Balik lang po natin yung ating design para hindi po malito yung ating mga participants here. Habang tinatype niyo po yung code, ayan, ibabalik ko lang po yung ating mga ginawa kaninang changes. Ayan. So, ayan, I think clear naman po, no? So, ayan. So, para sa ganun, makita natin yung mismong display na text. Makita niyo po sa lower screen ko yung serial monitor. Ito po. I-click lang po natin to. And meron pong magdi-display dyan mamaya na text. Okay? So now, start simulation na po natin. I-zoom ko lang po to para makita nyo na mag-on yung green at magta-type dito yung green LED is on and green LED is off. So start simulation. Ayan. So nakita nyo na po yung green LED is on, green LED is off, and then nakaloop po siya, continuous po lang. So green lang po yung magpapakita kasi green lang po yung nilagay natin. So para po malagyan yung gagawin po natin, itatype din po natin yung ganitong command sa ating iba pang code. Okay? So stop simulation natin. I-paste po natin dito sa orange. Okay? Paste natin. So instead na green, gawin natin orange. On. And paste dito sa baba. Orange. It's off. And then last one, we have the red LED. So red din dapat to. And yung off natin. And then red din dapat to. And then off din dapat to. Now once done, ang gagawin natin is to clear our screen. Dito sa ating serial monitor sa baba, clear screen. And start simulation na po natin. So makita niyo po dito na magdi-display din. Ayan na po siya. Green LEDs on, off, on, off. Ayan po siya. So tinitingnan ko po sa YouTube kung parehas po, no? Ayan. So the same po yung nag-a-appear sa ating YouTube.
Sir Dom, may problema pa din yung kay Ma'am Gemma. Kahit ano daw, hindi niya daw ma-copy-paste. Gemma, baka po hindi niyo na-highlight tapos copy and paste. Baka po kasi try niyo po ulit i-highlight, copy and paste. Naka-stop simulation daw kasi siya, sir.
Highlight niyo po yung text, yung code na gusto ninyo. And then Control-C.
Copy.
Highlight, Control-C. And then select niyo yung location. And then Control-V or paste. Ayan.
Yan. Ano ba ito? Ibig sabihin ng serial print? Yung serial print LN, serial print line po yan.
Yes
so,
po.
nagpiprint siya ng isang line.
Correct po. Ayan. Kapag sinabi, again, kapag meron pong LN, magka-create po siya ng line, panibagong line. Pero pag wala pong LN, the same line po yung mangyayari. Serial.print, kung serial.print, lahat po ng text natin nasa isang line po sila. Kapag wala po yung LN. Pag meron, as you can see, bumababa po yung text natin. Paki-zoom po yung code. Sige po, i-start simulation ko lang po. Sorry. I-zoom po natin yung code.
Ako din, sinom ko din. Duling ako. Liit kasi.
Sorry. Medyo maliit po talaga sa ating mismong screen. Ayan po yung ating code. Under void loop po ito, no? Ayan. Okay po ba? Okay. Yes.
Tama.
Pwede ba natin i-zoom sa mismong ma'am?
Hindi. Sa'yo lang.
Sa'yo
lang dapat.
Ayan po.
Parang kita naman. Okay naman siya.
Ang zoom ko po para kita.
Sir Julius, kaya mag-zoom.
Ayan. So, hintayin po natin yung iba, no? Siguro, Ma'am Jen, mag-time na lang tayo. Siguro, kaya 12 at 2 minutes?
Yeah,
Or
of
isang
course.
minuto? Apo.
Oo,
Para sa ganun,
copy-paste lang naman yan.
opo,
Maka-move on tayo sa madami pa.
Opo. Tama po, tama.
Oh my gosh, nawalan daw siya ng kuryente si Ma'am Arlene. OMG, wala na po talaga kaming magagawa dyan. Ha. Please say kung may space po. Ilang space po ang kailangan kasi error code po ang nagawa ko. Saan pong space, Mabuela?
Wait lang. Copy-paste po natin to, no? Pupunta lang ako sa YouTube ko so that pwede kong i-paste yung code mismo sa comment section.
Correct. Pa-copy na lang nila. Bait mo. Hindi ako pwede.
Ayan. I-paste, na-paste ko na po yung ating code pero sobrang haba po and hindi po siya organized.
Oo. So siguro paste mo sa Chong, sa notepad. Share ka notepad.
Okay. Sige po, ino-notepad ko po
para
muna.
Makita. Para ma-zoom. Para makita ng madlang chips. Ayan. Nag-error kami. Hahaha. Sa print, ay Mamuela, hindi po print IN. Print LN po, LN. Lowercase LN. Line, parang gano'n. Sa serial print. Zoom in mo yan, Sir Dom, para kita nila yung notepad mo.
Change ko lang yung font.
Giant fonts. There you go. Sige, Ma'am Gemma, masend ang pic. Chat kita.
Ayan, I think clear na po ata sa screen, no? Sige po, hintayin po natin sila.
Oo, tama. Yung may parenthesis, minsan yung semicolon po talaga, lagi na lang yan ang pampagulo ng buhay eh.
Opo.
Kailangan po nandyan yung semicolon. May doggy dito sa akin, teka lang, maingay ako.
Kung may dog po sa inyo, ma'am, meron pong manok naman sa amin. Kaya sabi ko kanina, yung manok mamaya, tinola.
Hindi ko matitinola yung doggy. Wag ganun. Bad yun.
Ayan. So, I think okay na po ata yung iba, no? Meron pa po ba? Pwede po kayong magtanong?
Yeah, meron naman tong recording, so don't panic po. Mahalaga na i-start nyo. Kaya po, Sir Dom, dapat i-save niya na to. Save na nila to kasi ito yung series 1, tama? LED?
Yes. Okay. Save nyo na po ito. Okay. I think
mamaya.
I-remove tong ating, ma'am, no?
Yes.
Okay, remove ko na po ito. Nabalik po tayo sa code. Ayan po. So, again, ganun po yung paggamit ng ating LED. Now, paano po ba siya masasave? Okay, napaka-importante pong sinisave, no? Automatic po na nasa-save to. Okay? So, kung mapapansin nyo po, dito sa aking upper right ng window ko, all changes saved. So, hindi nyo na kailangan mag-panic. Na-save ba to? Anong mangyayari? So, pag nag-brown out, kagaya nung isa kanina, automatic po na nakasave na yun. Okay? And paano natin to export? Okay? So, dito po export. Click nyo lang po siya. And then, meron pong BRD for circuit board layout. So, ito importante. Ito, ipakita lang natin. Click lang po natin to. Mada-download po yung ating circuit. Okay? Ito po. Ayan po siya. So, kung meron po kayong app na pwede nyong i-open, yung mismong BRD file, then it's good. Pero pag wala po, hindi nyo po ma-open. Now, paano nyo naman makikita lahat ng components? Sa upper right corner natin, meron itong component list. I-click nyo lang po yan. And then, ito po lahat ng ginamit natin. Ngayon, kapag gumagawa kayo ng research, napaka-importante na naka-specify dapat yung quantity, yung name, yung component. So, dito po, hindi nyo na kailangang i-type. Automatic po, kung ano yung ginamit yung component, lalabas na po dyan. Very helpful. And then you can download the CSV. Ayan. So, pag na-download nyo, makita nyo sa aking screen, na-download na siya, and then open ko lang po. So, open po siya yung sa Excel format. Ayan po yung Excel format. Ayan. So, naka-organize na rin po yan. Ayan. Sobrang galing po ng TinkerCAD. Okay? Balik po tayo sa ating TinkerCAD window. Ayan po siya. Okay? Ayan. So, click nyo lang po ulit yung circuit para bumalik po sa circuit design. Okay. So, since done na po tayo dito, proceed na po tayo sa next na topic natin, which is paggamit ng button. So, tapos na tayo sa LED, sa serial monitor, punta na po tayo sa mismong button. Okay? So,
Wait
do
lang,
that.
sir. May question dito kay sir. May question si Ma'am Cheryl. Marami po yan, Ma'am Cheryl, no, na mahahanap ka na codes. Pero ang focus po natin muna ngayon is hard code. No, Sir Dom? And then yung kay Ma'am Gemma pala, ang issue, baka po meron pa rin ibang gano'n. Ang issue is nasa black and text siya. Kaya hindi siya makapag-paste. Sa text lang po tayo. Sir Dom, pakishow mo nga sa kanila ulit yon.
Ayan.
Yung paano
So,
po may yung black and text and ano lang.
Paano po tayo makapunta sa text? So, yung code, again po, yung code, click nyo yung code. Ito po yung, kasi black and text po kayo, no? Ito po yung nangyayari. Dapat po, nandito kayo sa code na to, and then, select nyo po yung text lang po. Text. Ayan. Yan, babalik po sa dati yung aking program. Kasi, yun po yung mangyayari talaga, babalik sa dati.
Nawala.
So, dapat, nasa text lang po kayo. Ayan. So, I think, so much for LED and serial monitor. Pwede na po tayo mag-proceed kasi it's already 11. So,
1 hour na lang.
1 hour na lang, no? So, back po natin to. Or, dito na lang po siguro, Ma'am Jen, dagdagan na lang natin to. Tama?
Pwede. Pero kung gusto nang i-store yung bilisan lang nilang maglagay ng mga components na nilagay nila kanina. Carry na nila yan. Mabilis naman sila.
Tama po. Now, i-remove ko na po tong ibang components. Di-delete ko na po to, ha. Yan. So, select nyo lang yung component, press yung delete sa inyong keyboard. Ayan po siya. So, dinelete na natin, no? Ang gagawin po natin, gusto natin, i-on natin yung LED, hindi automatic. Ang gusto po natin, i-on natin yung LED upon pressing the button. Okay? So, may button na po dito. So, para po magawa natin yun, hanapin po natin yung button, yung push button, sa ating components. So, ito lang po siya. Okay? So, click and drop po natin siya. So, i-drop po natin dito sa mismong E10. Yan po. I-zoom ko lang po ng konti para makita nyo po, no? Ayan. So, hintayin ko po kayo, no? So, nasa E10, yung terminal 1A, terminal 2A sa E12, and terminal 1B sa F10, and terminal 2B sa F12. So, sige po, hintayin ko po kayo. Ayan, pakita po natin sa ating screen. Ito po ay push button. Ito po siya. Ayan. Kapag malabo po yung nasa screen, pwede nyo pong palitan yung settings mismo sa YouTube. Yung icon na gear, itaas nyo lang po yung mismong quality. Gawin nyo pong 720 or 1080 po yung resolution. Ayan po. Okay, so okay na po tayo sa push button. Next na gagawin po natin ay magdadagdag po tayo ng, of course, resistor. Okay? So, click po natin yung resistor. And then, tong resistor na po na ito, ilalagay po natin dito sa ating terminal na nasa E12. So, i-connect po natin siya sa negative papunta sa B12. Ayan po. Negative and then B12. Okay? B12, terminal 2A, negative, and then B12. Ayan po. Pasundan na lang po. Habang tinitignan ko po yung ating YouTube kung may tanong. Ayan. I think clear. Then, again, yung ating terminal 1A, i-connect po natin yan sa ating positive. Okay? So, terminal 1A, pwede po dito sa D10, and then sa positive po natin lalagay. Ayan. Palitan po natin yung color, make it red. Kasi positive po siya. Okay? Then of course, i-connect po natin sa breadboard yung ating Arduino, yung 5 volts. Kuha po tayo dito. Ayan. Okay. And then, select po natin to. And next thing to do po, ay kailangan
palitan natin yung kulay and make it red. Ayan po siya. So meron na tayong source for negative, meron na tayong source for positive. Okay po? The next, isa pa po sa mga pinaka-importante, gaya ng sabi ni Ma'am Jen kanina, depending on the value of the resistor. Atong push button po ay nagre-require siya ng mas mataas na voltage or ng electricity. So, which means to say that, itong resistor, kailangan natin itaas ng konti. Okay? So, how to do that? You simply select your resistor. And of course, palitan po natin yung resistance. Yung resistance po gagawin natin 10K. Okay, 10. Ilagay po natin 10. Alright? And after that, next thing to do ay kailangan na po natin i-connect yung ating terminal, ito po, terminal 2P sa ating digital pin. Anywhere po, anywhere. But again, kung sinabi natin anywhere, dapat po mamaya sa code, dun din po siya nakalagay. Okay? So, piliin natin tong H12 at i-connect po natin siya sa pin, sabihin po natin sa digital pin 7. And change po natin yung color. Okay? Sabihin po natin ng color para may iba naman ay blue. Ayan. Tayin po natin yung iba. Sige po. Check lang po natin, check ko lang YouTube. Ayan. So, 30 seconds po para magtanong, 30 seconds to 1 minute. Ang goal po natin dito ay kapag pinindot po natin yung push button, mag-on po yung green LED. So, dito po medyo merong tinatawag na conditional statement. Merong if function, if command. Okay? So, merong comparison between values, between components, between variables. Okay? So, gagamit po tayo ng conditional statement ngayon. Okay? So, habang itatype ko yung code, makinig po muna kayong lahat mamaya para sa ganun, mas maintindihan nyo yung gamit ng mga code na nilalagay ko instead of actually typing it also sa inyong circuit. Okay? Ayan. Siguro, Ma'am Jen, 30 seconds muna tayo, no? And 1 to 1 minute.
Sa tanong na ba? May tanong kasi dito. Medyo malabo sa screen. Minsan po yung connectivity nyo po ang problema. Malinaw po kasi sa amin, minsan sa inyo po blurred. Kasi yung transmission siguro, hindi masyadong naabot. No? Pero kung medyo zoom in, ang nahihirapan po talaga yung naka-mobile device eh. Pero sa laptop.
Mobile device. Wala pa po tayong code, Ma'am Denny, Sir Dennis. Nasa circuit pa lang po tayo.
Ano pa bang kailangan natin tandaan dito? Okay naman so far noon. Kung kayo po ay nasisikipan dahil pwede nyo pong i-click, kung katulad sabi ni Sir Dom kanina, pwede nyo i-rotate yung device para hindi siya lateral. Medyo, kasi yung akin, pares kami ni Sir Dom, OCD na ako sa wire, kaya yung mga estudyante ko tinatanong, ma'am, pantay-pantay ba dapat? Ma'am, dapat ba pares kulay? Ganun kasi, para pag nag-build sila sa actual, malinis yung wiring, hindi siya parang octopus wiring ang dating. No? Kailangan masanay sila sa virtual pa lang, malinis yung board, kita yung components, hindi patong-patong, para madali ding mag-check. Kasi kayo din ang mahihirapan kapag parang spider's web yung inyong wiring, tapos kayo yung mag-check. Siyempre, checkan din natin yan as teachers, di ba?
Ayan.
So, ayun na, sabi ni Principal Wax.
Ay, si Sir Wax.
Patakot si Sir Wax pag lumalabas, parang papagalitan tayo. No?
Oo nga po. Ayan, baka may katanungan po si Sir Wax.
Sir Wax, may tanong ka ba? Paki-zoom po daw sa code, sabi ni Sir Dennis.
Ayan, wala pa po tayong code.
Wala pa tayong code. Ay, yung code kanina na naka-notepad daw po.
Yung notepad natin. Sorry. Sige. Yan.
Picturean nyo po para...
Picturean nyo na lang po muna. Screenshot.
Screenshot. True. Kaya lang may live dun sa corner. Paliitin mo, sir. Para hindi na tatakpan.
Ayan. Screenshot po. Screenshot.
Saka pwede nyo po itong balikan. We are recorded then.
Oo.
Ilalagay ko rin to sa aking YouTube channel. Lalagay din ni Sir Dom at ilalagay din ng Felta. So lahat po kami ay mag-share ng info. So don't worry. No
Yes.
teacher and
Ayan.
child left behind.
Yes. Yan. I think, Ma'am Jen, okay na tayo. Proceed na po tayo.
Yes
No?
po. Yes.
Ayan.
Correct.
Ayan. So, cheers. Assuming na natapos nyo na po yung mismong circuit design, punta na po tayo sa code. Again, yung ating resistance dito, tinaasan po natin yan. Ginawa na po natin 10K. So, baka po makalimutan yung gawing 10K, hindi po gagana yung inyong push button later on. Okay? 10K ang ating resistance. And balik na po tayo sa code. Ito po ulit. Kailangan po yung code ay text. Okay? Kailangan po yung code ay text. So, how to change? Select po natin yung, di ba naka-blocks po yan? Select po natin yung code and, blocks and then text and then continue. Ayan. So, meron pong default na code dyan. Now, punta na po tayo sa mismong program natin. Okay, punta na po tayo sa mismong program natin. So, habang ginagawa ko po to, tignan ko lang po kaagad yung YouTube natin para sa ganun, makita ko po kung merong question, ma-post po natin baka para sa ganun, hindi po tayo ano. So, meron tayong ginamit na LED pin 13. Okay? And then yung ating push button na nakalagay sa digital pin 7. So, ang gagawin po natin, cheers, dito, we need to what? To use a conditional statement para sa ganun po ay pag ginamit natin yung conditional statement na yun, gagana na po yung ating mismong push button. So, first, kailangan po nating i-declare yung ating component na yun. Yung push button po natin, ano po ba yung push button? Pine-press po natin, which means to say this is an input. So, pin mode 7 po, and then input po dapat yan. Ayan. So, pin mode 7, input. Okay? So, dapat input po siya. Ang next na gagawin po natin is to simply read yung ating value para sa ating push button. So, paano basahin yung value na yun? Remove ko muna to lahat. So, para mabasa po natin yun, kailangan nating i-display yung value muna. So, serial.begin, 9,600. Ayan po. Ito po ay code para sa ganun makapag-display tayo. And then, serial.println. And, maglagay po tayo ng double quotations here. This means string the button value is. So, ilalabas lang po natin yung value ng button. Yes. And then serial dot print. And then, ano po yung gagawin natin? Kailangan natin kunin yung value ng button. So, ibig sabihin, we need the digital read. Bakit nga ba siya digital read? Digital read po siya kasi nasa digital pin po siya. Zoom po natin yung code. Ayan po. Ito po yung code natin. Ito yung sa LED natin, cheers, no? So, serial.begin, and then declare natin na input yung ating pin assignment sa 7. And then, wrong spelling. Ayan. So, the button value is and serial.println digital read 7. Kasi nasa 7 po yung ating button. So, sa baba, maglalagay po tayo ng konting delay. So, magde-delay po tayo dito ng, let's say, 200 milliseconds. Ayan po siya. Now, kapag niran po natin to, ang mangyayari po dyan, kailan po natin to, pakita po natin yung ating screen. Ayan. Pag i-run po natin to, makikita niyo po yung output dito sa ating serial monitor. So, i-run ko na po siya. Okay. Ayan. Ano po yung, clear ko lang muna po. Yung lumalabas po sa ating screen, palitan ko lang po to, cheers, kasi dapat nandito po yung LN natin. Ayan. So, ang lumalabas po sa ating screen is the button value is 0. Bakit po 0? 0 po yung lumalabas kasi hindi po natin pinapress yung ating button. Ngayon, ipapress po natin yung button. So, using our mouse, nakapress po yung button natin. So, ang lalabas po dyan ay 1. Ibig sabihin, naka-press po yung ating button. So, kita nyo na po sa screen, no? 1 na po yung lumalabas. Ayan. Tama po, 1. Ayan. So, kapag tatanggalin ko po yung pagkaka-press, of course, magpapalit din po yung value. Parang sa actual po na circuit, 1 is on, yung 0 is off. Ayan. Ayan. So, okay na po tayo dyan. Stop simulation po natin. Now, gaya ng sabi ko, ang goal po natin is to turn on our LED kapag press po natin yung ating push button. So, that means kasi kailangan natin ng conditional statement or ng function. Okay? So, how to do that after po ng ating delay? Remember po kapag 1, dapat naka-on yung LED. Kapag 0, naka-off po yung LED. So, dito po, lalagay po natin ang if, okay? If digital read, and then yung 7 is what? Equal. Kung equal ba siya sa 1? Ang ibig sabihin po niyan, kapag naka-on ang ating LED, ano po yung gusto natin gawin? So if ang LED ang push button natin ay 1 or pinindot natin ang button natin, i-on po natin yung LED. So sa loob ng if, lalagay natin digital, right? And then 13, kasi nasa 13 yung LED, high. Ayan. I-on po natin siya.
Mazuzoom mo ba yung yung text?
Ma'am?
Pa-zoom in daw ng konti yung code, maliit.
Pa-zoom in. Ayan po. Okay na po kaya to?
Yan. Carry na yan.
Ayan. Carry na. Okay. So, again, ang digital read 7 natin, ito yung comparison. Kino-compare natin yung value ng push button natin. Kung ang value ba ay 1. Ngayon, kung 1, ibig sabihin po nun, kailangan natin i-on yung ating LED na nasa pin 13. Ngayon, kung hindi naman, meron tayong tinatawag na else, ang gagawin naman po natin is to simply turn off our LED 13 and then low. Yan po. No need for delay. Bakit no need for delay? Kasi ang gusto natin, kapag pinindot lang siya, doon lang siya mag-on. Hindi siya mag-on ng specific time. Kapag hindi naman natin pinindot, mag-off siya automatic. Hindi lang siya mag-off in specific time. So kaya po wala tayong nilagay na delay. Okay, so I think ready na po tayong simulate yung ating program. So pakita lang po natin dito. And then start simulation. As you can see po, no, sa ating serial monitor, ang value ng ating button ay 0, which means to say naka-off po yan. Kapag click ko po yung ating push button, makita niyo na magwa-1 yung value. And at the same time, mag-on po yung ating LED. So, i-click ko na po to. Ayan po. Naka-hold po yung aking left click sa aking push button. So, makikita niyo po na naka-on yung ating green LED. Ngayon, kapag tinanggal ko po yung aking pointer sa ating push button, makita niyo po na mag-off ang ating LED and at the same time, yung value ay magiging 0. Ayan. I think clear po tayo doon, no?
Sir,
clear
pabalik daw sa code.
Pabalik daw po sa code.
Tingin ulit daw ng code.
Okay po, ito po yung ating code. Sobrang maiksi lang. Okay na po ba?
Medyo malabo kasi no kung anong siguro na confuse sila sa curly bracket at saka parentheses.
Ito
Kasi
po
hindi masyadong ma-identify sa video.
Oo. Siguro i-copy paste ko na lang to, no? Sa notepad. Lagay ko lang po sa notepad.
Oo.
Ayan po yung ating code. Ayan po. So, nilakyan natin. Curly bracket po mga to. Yan, para po differentiate ninyo yung parentheses and curly bracket.
Oo. Sabi ni Sir Wax, malaki siya sa malaking screen. Eh, naka-cellphone nga sila, Chong. Kaya hindi nila makita. Ako nga hindi ko makita. Laki na nga ng mata ko at ng screen ko eh.
Nilalagyan ko po ng comment, ma'am, para later on pwede nilang balikan.
Oh, tama. At saka case sensitive po talaga kasi siya. Isang maling tuldok, isang maling kulang na semicolon, talagang hindi talaga siya gagana. So, dapat po kung ano talaga yung code, yun talaga.
Ito pong tinatype ko, Church. Ito po ay comment, yung may slash. So kahit hindi nyo po kopyahin yun, okay lang. Pero importante po na malaman niyo kung ano ba yung function ng bawat code. Ayan. So I hope na naka print screen na po kayo. Na print screen nyo na po or nakopy nyo na po tong code na to. Picturean nyo na po kaagad. Okay. I think, Ma'am Jen, okay na, no? Pwede na tayo mag-proceed?
Yeah, pwede naman din kasi talagang balikan. Yes.
Okay,
Para
so pwede
makarami
na po
silang
balikan.
ma-practice.
Yes po, tama po yun. Now, so, okay na po tayo doon sa ating button. Ngayon, kung gusto niyo pong magdagdag ng button, same procedure po, ipakita lang po natin, no? Parang LED lang din, ayan po siya. So, ganun din po, resistor, and then yung value dapat 10K, and then red dito, palitan natin yung color, red, medyo binibilisan ko na, Ma'am Jen, para madami tayong matapos. And then here, connect po natin to sa anywhere, sabihin natin sa 6th. Ayan. Okay? So, kung gusto niyo lang po, no, halimbawa, pag pinindot natin to, mag-on yung another LED, pwede lang po yan, no problem. As long as tama po yung code, as long as tama po yung circuit design. Okay po? So, siguro 1 to 2 minutes ulit para magtanong and then proceed na po tayo sa sensor and potentiometer, Ma'am Jen. Ito yung last part natin sa
Sa una, no? Sir, patingin nga ulit ng code. Isang tingin na lang kasi maraming nag-PPM ng, ayan. Ayan, okay na. Yan, pwede na tayo sa susunod, sir.
Okay. Ayan. So, since okay na po tayo, gagamitin na rin po natin to, itong same, or panibago na lang po tayo, no? So, mag-back lang po kayo and then create kayo ng panibago. So, sa part ko, hindi ko na po kailangang baguhin. So, ang gagawin ko na lang po, i-delete ko na lang po itong mga components para sa ganun, mabilis na lang po. And again, meron pa rin yung LED natin, no? Now, magdadagdag po ako ng isang sensor. Okay? So, yung sensor po na yon ay ang hanapin po natin ang temperature sensor. Ito po siya. TMP. Temperature TMP36. Okay? So, kaya niyo pong mag-detect ng environmental temperature. Okay? So, click lang po natin siya and i-drop po natin sa ating mismong breadboard. Ayan po, dito natin lagay. Zoom lang po natin. Ayan. So, makikita niyo po dito na merong 3 legs. Ang ating temperature sensor, meron tayong power, meron tayong Vout, meron tayong GND. Of course, again, kapag sinabi natin GND, this should be connected to our negative power. So, dito siya. Change the color, make it black. And then yung ating power, this means it's positive, then this should be connected to our positive also here, and then make it red. Nakalimutan po natin na lagyan ng power. So 5V, i-connect po natin yung 5V natin sa ating, yan po. And then, gawin din po natin tong red. Ayan. So, hintayin po natin yung iba. So, again, power is positive red. GND is negative black.
Nadi-disconnect ako. Wait.
Okay. And then, of course, kailangan na po nating i-connect yung mismong Vout natin. Pag sinabi nating Vout, ito po yung kung saan natin i-connect yung ating temperature sensor para sa ganun magbato po siya ng value, analog value. So, select po natin to and then connect po natin siya sa ating mismong, sorry. Yan, connect po natin siya sa ating analog 0. Ito po siya. Ayan. So, nilagay po natin siya sa analog 0, no? Ayan. So, green ang ating color. Palitan po natin siya, gawin natin blue. Kahit anong color po, basta wag red and black ulit. Ayan, so blue ang ginamit natin and it's connected to our analog 0. Okay? Then, of course, ready na po tayo para i-program yung ating temperature. Para makita natin kung ano ba yung temperature. Okay? So, balik po tayo sa code. Ito po yung code natin kanina. Remove na lang po natin to. Hindi na natin kailangan. Now, ang gagawin ko po, remove ko po lahat para sa ganun mas masundan ninyong mabuti. Okay. So, meron tayong serial.begin. Kailangan natin to para ma-display yung mismong value ng ating temperature. Sa loob ng ating void loop, kailangan po nating i-type ang serial.println or .print, and then sa loob po niyan, ilalabas po natin yung the temperature value is. Ayan. And then of course, meron tayong serial.println yung ating analog value. It should be analog read. Kanina, digital read, no? This time it's analog read. And then yung A0. Ayan po siya. Then maglalagay tayo ng delay. Kaano siya katagad? Mag-display ng value. Sabihin natin na in every 1 second po, nagdi-display po siya. Okay. So, para po makita natin yung value, kailangan lang po natin i-start simulate. Pakita naman natin yung screen. Clear screen. Start simulation. The temperature is 153. As you can see in my screen, it's temperature 153. Para po mapalitan yung temperature, ang gagawin po natin, i-click lang po natin yung ating temperature sensor. Pwede nyo po siyang i-move ng ganito. Habang minumove nyo po siya. Kunyari lang po, no? Ito yung mismong temperature ng environment. So, kunyari, minumove natin siya. So, 77. So, 77 din dapat po yung magpakita sa ating screen. So, ganun po yung gamit ng temperature sensor natin. So, as you can see, sa aking screen, it's 262. Okay? Ayan po siya. Ayan. So, nagbabago po siya depending sa gusto kong temperature. Ina-adjust ko po kasi siya dito. Again, yung lumalabas po sa ating screen is Fahrenheit. Kung gusto ninyong i-convert into degrees Celsius, centigrade, meron pong proper mathematical equation para sa ganun. I think it's, so kung kayo pa math teacher, alam niyo na po siguro, and science or physics teacher, kung paano yung equation on how to convert Fahrenheit to degree centigrade. Ayan, Ma'am Chen, I think, tingnan ko po muna sa ating YouTube kung meron mga katanungan. Ayan, so meron pong katanungan dito na...
Sir Dom, question ni Annalyn Abayhon, kung anong value ng serial begin with 9600?
Ayan. So, Ma'am Annalyn, ang serial.begin 9600 or 9600, ang ibig sabihin po niyan ay yan po yung baud rate. Kapag sinabi po nating baud rate, yan po yung connection between our computer and our microcontroller board. Okay po, ulitin ko po. Yan po yung connection ng ating computer and ating microcontroller board. And in which means to say that gaano siya or yung speed ng pagbato ng data from your computer going to Arduino and vice versa from your Arduino papunta po sa inyong computer. So it tells the Arduino board or the computer at the same time to get ready para mag-exchange po sila ng data. Okay? Kaya po, serial.begin 9600 po. So yan po yung bits or bits per second po. Yung exchange, kumbaga exchange rate, kung sa pera po currency, exchange rate din po. And meron po pang tanong, I think dito kay Ma'am Cheryl. Posible po kaya na mabigyan ng copy ng slide presentation?
Parang,
alam po tayo, Ma'am Jen, na i-share yung slide ko?
Actually, kahit mag-share tayo ng slide, medyo mahirap din nilang i-follow kasi marami tayong spill, no? Pero pwede nyo balik-balikan tong video na ito para mas madali kasi nandun yung explanation. Ako nga nagte-take notes ako kasi hindi pa ako expert dyan sa Arduino ba. More on ano kasi ako, hardware. Hindi ako masyadong, hindi ako coder masyado eh. So, pinupush ko lang yung mga students ko ng code na ganyan. Pero yung tanong mo kanina, dahil math teacher ako, maganda talagang gamitin tong TinkerCAD para sa sa pagtuturo ng conversion, especially in math. Now, sabi mo nga Fahrenheit ang lumalabas, may formula tayo diyan, 32 degrees Fahrenheit minus 32 times 5 over 9 equals 0 degrees Celsius. So, ang maganda lang dito sa Arduino, you can practice yung tamang pag-type ng formula, no? Kasi kahit tama yung formula mo, pero mali yung pagkaka-type ng formula mo using arithmetic operator sa code, wala din, hindi rin gagana. The use of the parentheses, hindi ka pwedeng gumamit ng X kasi variable yon. So, dapat asterisk for multiplication, di ba, Sir Dom? Medyo, yun yung mga magandang ituro dito.
Yes po. Tama po yun. So, kayo na lang po later on yung mag-convert dito ng kung paano i-convert yung Fahrenheit to degrees centigrade. But, kailangan nyo po ng tinatawag na variable. So, ngayon, i-explain ko po sa inyo kung paano ba ginagamit si variable. So, importante po si variable. Ang ibig sabihin ng variable is temporary storage of known or unknown value. Kung hindi natin alam yung value ng specific sensor, specific component, then we use variable. We declare variable in replace of that component or in replace of that sensor. So for example, ito, ang ginamit po natin ay temperature sensor. Ngayon, gagamitan po natin siya ng mismong variable name na upang sa ganon, kahit gamitin po natin multiple times yung ating variable na yon, hindi tayo mahihirapan, okay? Or yung ating sensor na yun. So dito, pwede natin mag-declare ng int. Ano po bang ibig sabihin ng int? Ang ibig sabihin po ng int is an integer. Integer means it's a decimal value. It's decimal kasi positive or negative whole numbers ang kanyang ina-accept. Hindi po pwede ang may decimal places. Pag sinabi kong decimal value, positive, negative po ito. Not with decimal places. Okay? So int, let's say int temperature. Okay? Temperature sensor kasi. So pwede natin gamitin short na temp. Okay? Is equal to 0. I-declare muna natin na ang value ng ating temperature sensor ay 0 for the meantime. So yung temperature sensor na yan, pupunta siya sa temp na ating variable. So pwede bang X? Yes. Pwede ba ang A? Yes. Pwede bang B? Anything, any name, pwede. But then, as a good programmer, as a good practice, kailangan po, we name our variables specifically proper name kung ano ba yung gamit ng variable na to. If it's for temperature, then it should be for temperature. That's why it's int temp. Int is a number. Kasi number po yung dinidisplay natin. That's why it's integer. Okay? So 0 kasi we don't know the value of our temperature sensor. Now, going back to our loop. Dito, ang dinidisplay natin is the value of temperature. So pwede na natin gamitin mismo yung ating temperature na variable. So meaning, dito is ilalagay natin temp is equal to the value of our analog grid. So ito, kakopy po natin to. C, and then paste it here, and then we add semicolon here. Ayan po siya. Then remove this thing later on. Okay? So, ang ginawa natin is we what? We transfer the value of our analog sensor, temperature, at nilagay po natin siya sa variable na temperature. Here po. Ayan. Transfer na po natin siya sa variable na temperature. Make sure po na kung small letters dito, it should be always small letters also here. Now, dito sa analog grid na to, hindi na po natin kailangan yan. All we need to do is to type temp here. Bakit po temp? Kasi yan po yung value, yun po yung variable na ginamit natin para sa ganun, kumuha ng value ng analog grid natin. Okay? So I hope clear po yun, no? Paggamit ng variable natin. Ayan. So dineclare natin yung variable, na temp, initialize natin na 0, and then sa loob ng void loop, kinuha natin yung value ng analog sensor natin, nilipat natin sa temperature, and then sa loob ng serial print natin, nilagay na lang natin yung variable name. Similar po sa ginawa natin kanina. Same output po. Kung gumamit kayo ng ibang variable, well, it's okay. As long as make sure na dapat parehas po sila. And para makita natin yung output, i-simulate po natin yung mismong code ng ating, it looks like some errors. Sorry, wala po tayong, nakalimutan po natin yung mismong, the temp was not declared, and ito yung sinasabi natin kanina, na kapag hindi natin na-declare ng mabuti yung ating variable. So ano dapat yung tamang way para sa ganun, ma-access natin yung ating variable na temp? Ano ba dapat or saan ba dapat yung tamang way? Ngayon, itong int natin dito, church, kung mapapansin nyo, gaya ng sabi ko kayo, nasa void setup. Ibig sabihin po nun, nasa void setup lang po siya. Kung nasa void loop naman, kung ililipat po natin to dito, ibig sabihin po niyan, pwede mo siyang ma-access kahit saan. Ngayon, meron pa pong isang tinatawag na declaration dito sa labas ng void setup natin. Before mag-void setup, pwede po tayo mag-declare ng int temp equal to 0. Ito po, ang declaration po ng tinatawag na to is public declaration or public variable. Yung nandito po sa loob na to, this is a private variable. Wherein, kapag nasa loob ng void loop lang or kapag sinabi natin private variable, doon lang siya mismo sa location na yun ma-access. Ngayon, kung public variable naman, anywhere sa code, kung nasa void setup man or nasa void loop man, makukuha nyo pa rin po yun. Okay? Halimbawa po, tanggalin po natin to. Subukan natin run kung gagana. Ayan. So, makita nyo po sa aking screen na yung value ng ating temperature is 153. 153, same po yung kanina natin. Okay, same. Kasi, meron na po tayong variable inside our void loop. Yung una nating ginawa is inside void setup. Na-explain ko po kanina na kapag void setup, isang beses lang at doon lang siya, doon lang magra-run yung program. So since nasa iisang blocks of codes na tayo or function na void loop, gagana na po yung ating code. Ngayon, kung tatanggalin po natin to, stop simulation natin, kapag tatanggalin natin yan, and ilalagay po natin before the void setup, ano po kayang mangyayari? Start simulation po natin. Parehas pa rin ba kayong output? The answer is yes. Gaya ng explanation ko kanina, nasa taas po siya. Ibig sabihin, naka-public declaration. Ibig sabihin, kahit saan po sa inyong code, pwede nyo gamitin yun. Okay, kahit saan. Sa code din nyo pwedeng gamitin. So that's how you use variable. That's how you declare variable. It's very case sensitive. Okay? Now, copy ko lang to. I am pretty sure na kailangan nyo ng code. So ito po siya. Ayan po siya. So nasa declaration na po ng public natin. Public declaration na po tayo. Ayan. Sir Dom, can we use other serial frequency instead of 9,600 when we can use other serial frequencies? Sir, yep. Sir Ronald, pwede po natin gamitin yung iba pang frequencies. For example, 11,520, 5,200, or other frequencies, yes. As long as yun pong frequency na yun ay nababagay sa component na ginagamit natin. Let's say, ang gamit natin na frequency ay sa Arduino board natin. So, other frequencies, pwede nyo pong i-type yung other baud rate sa mismong Arduino. So, marami po tayong baud rate na tinatawag sa Arduino. Depende po kung ano pong component or depende po kung anong board ang gamit natin. So, ilan sa mga ginagamit na tawag din na baud rate or frequency is meron tayong 38,400, meron tayong 19,200, meron tayong 4,800. Depende po yun kung ano yung gusto nating gawin. Ayan. Tinitingnan ko po dito sa mismong YouTube yung mga katanungan. I think yun lang po yung katanungan from Sir Ronald, yung different frequencies. Okay? So marami pong frequencies na available. Depende po yun sa Arduino board na gamit natin. Okay? Speed, yun po yung speed. Okay, bits per second po. Yan. Ma'am Jen, pwede tayong mag-entertain ng katanungan kung meron tayong katanungan dyan?
Yun. Kumakaway-kaway nga ako eh. Ayan. So, importante talaga yung mga declaration ng variable. So, mapapansin nyo po, sobrang technical talaga. Hindi natin kayang i-cover in 2 hours. Kasi nga, 30 minutes na nga lang natitira. Parang feeling ko wala pa tayo sa kalahati, Sir Dom. Pero, ang dami-dami pa talaga. Pero, mas importante po sa amin yung makuha nyo yung core. kaysa yung madami kasi madami naman pong other resources besides this. So yun yung mga technical details. Questions also dun sa pin, ano? Sabi na nga namin kanina ni Sir Dom, importante as a coder you label your variables at isulat. Kasi pag madami ka ng component na nilagay, mahihilo ka talaga sa paghahanap at pagto-troubleshoot. Ang maganda lang po dito sa simulator, hina-highlight niya yung line na may problema, di ba, sir? Tapos, binibigyan ka niya ng clue. So, yun yung maganda dito. Pag nagkamali ka ng isang component, sasabihin niya sa'yo kung saang line may error.
Ayan, tama po. Thank you, Ma'am Jen, no? And then, I think, konti na yung time natin, Ma'am Jen. Gagamitan ko na po ito ng application sa real life. Halimbawa po, no, saan po ba nakikita ang application ng Arduino ng ginagawa natin? Sa mga high-tech na bahay, kapag pumasok ka sa bahay nila, automatic nag-on yung light. Kapag nadidetect po niyang may tao, automatic nag-on yung light. Or automatic kapag madilim, nag-on yung light. Or automatic nagbubukas yung gate. Or automatic na, let's say, mataas yung temperature, sobrang init. Automatic mag-on yung aircon. Or kapag malamig na yung mismong room, automatic mag-a-adjust yung aircon. I-adjust niya automatically. So, ilan lang yan sa mga pwede natin gawin using Arduino. Posible pong gamitin ng Arduino. Hindi po to limited sa prototype lamang. Hindi po. Posible pong gamitin to sa lahat ng bagay. Pero again, merong proper microcontroller board para sa mga application na yon. Okay? So ngayon, Ma'am Jen, I think pwede na natin gamitin, integrate yung realidad sa mismong TinkerCAD natin.
Oo, tama. At saka yung, 'di ba, series natin, animal series. So, 'di ba nagpagawa tayo ng baler ng house ng sa ating Arduino, sa AutoCAD. So,
Yes,
ito naman, ang ating TinkerCAD, we can simulate how can we make sure na safe yung ating mga animals doon sa mga pinatayo nating pinapagawa nating design. So, ito naman yung electronic component magiging smart dog house. Ano ba yung itsura ng smart dog house?
Oo.
Sir Dom, parang mga ganon. So, sa bahay pwede rin sa animals.
Tama po yan. Ma'am Jen, yun sa smart dog house na ginawa sa AutoCAD, meron ka bang picture ng mismong design? Pero kung wala, okay lang. But, paano yung katanungan mo po, ano nga ba yung itsura ng smart dog house or yung smart house ng animals? Sabihin natin hindi lang sa animals, sa agriculture, sa farming, or sa iba pang part, no? So, ano ba yung itsura nun? So, Ma'am Jen, meron ka ba yan? Yung 3D design or wala
pa silang actually magagawa kami ng 3D modeling after. Kaya lang hindi namin alam pa kung ano yung mismong component, no? Pero bibigyan na natin ng idea how to wire it up. Yun yung ating objective sa pag-apply mo. So we are thinking of smart house, a sustainable house most likely, or a safe na house or dog kennel, whatever they wanted to create. Yun yung magiging output din nila and we'll comment later kung ano yung hashtag na gagamitin and where to submit.
Okay. Yes, thank you Ma'am Jen, no? So yung output po pala ninyo ay yung smart dog house. Ngayon, ano po ba yung smart na tinatawag? Smart kapag ito ay may mga automation, innovative design, no? So let's imagine na yung smart dog house ninyo, kapag pumasok si dog or kapag pumasok yung mga animals, ano po ba yung gusto nyong gawin sa loob ng bahay? Do you want to turn on the lights? Do you want to simply ventilate or bigyan ng konting lamig yung loob ng bahay? Gusto niyo po ba na medyo merong mga UV lights para sa ganun pagpapasok na yung alaga natin medyo ma-filter po yung mga bacteria or viruses or something like that na nakuha niya sa labas? Yun po yung mga ilan lang sa pwede natin gawin. So let's just imagine sa TinkerCAD natin, itong TMP na to, since this is a temperature sensor, imagine po natin na itong temperature sensor ay nasa loob mismo ng bahay ng ating alaga. So ano po ba ang pwede natin gawin sa temperature? So sa loob ng bahay, kapag mainit na, sobrang init na, of course, kailangan nating i-make sure na yung mga alaga natin ay well ventilated. Kasi kung hindi, mamamatay po talaga sila. So itong temperature sensor natin, gagamitin natin yan to turn on a specific component. So ano po ba yung component na yon? yung component na yon ay electric fan or sa totoong buhay, electric fan or aircon. Tama, Ma'am Jen?
Ayan, nawala ako. Okay, yes, tama. O kaya exhaust fan, whatever you feel like placing in there.
Ayan. So maglalagay na ako ng electric fan dito. Let's imagine ang electric fan natin is a motor. A DC motor. Ito po, DC motor. Ayan. So idadrop ko na po si DC motor natin sa ating breadboard. So lalagay ko siya sa mismong breadboard natin. Nandito po siya, no? Sa mismong F27. And yung terminal 2 natin is nasa F29. F27 and F29. Ito yung motor na to ay imagine po natin, this is our electric fan. Sa totoong buhay, ganyan din po yung code na gagawin natin. Ganyan din yung circuit na gagawin natin. Okay, so now, meron dalawang legs na kailangang i-connect natin sa ating Arduino. Terminal 1A is negative since ito ay black. So, click lang po natin to and then i-connect natin sa negative natin. Ayan po siya. Adjust lang po natin ng konti to. And then of course, meron tayong terminal 2 na red which is connected. Dapat po, saan po kaya ito nakakonect? Sa ating digital pin. Not in analog, but it's in digital pin. Okay? So click po natin tong F29 and then i-click po natin dito, i-connect po natin siya, sabihin natin nasa digital pin 7. Ayan. So nasa digital pin 7 na po yung ating connection. Again, this is the application of Arduino sa inyong mga smart dog house. Okay? So, ito yung electric fan, ito yung temperature sensor, ito yung LED. So, imagine natin na kapag tumaas yung temperature ng ating bahay, magbibigay ng signal, mag-iilaw. Kunyari. And then, mag-on yung electric fan natin para hindi mainitan yung ating alaga. So, how to do that? Palitan po natin to. Gawin po natin siyang red. And then ito, gawin po natin siyang green. No, not green. Of course, it should be black. And so smart house, ito na po. Gagawin na po natin yung code natin. And punta na po tayo sa code. Ayan. Siguro mga 10 seconds lang para makita yung circuit design natin. And so again, ang ginagawa natin ay automatic na pag-on ng electric fan or ng aircon kapag pumasok yung alaga natin or kapag masyadong mainit yung loob ng bahay ng alaga natin. Pwede pong multiple electric fans dito, Chers, ha? Hindi po limited sa isa lang. Okay? Pwede po tayong magdagdag mamaya ng isa pa. Pwedeng may buzzer, pwedeng wala. And now, punta na tayo sa code. Ito yung ating initial setup. Okay? And of course, kailangan po natin i-declare yung ating ginamit na pin, which is yung pin mode. 7. Ano ba yung 7? Kailangan po, yan ay naka-output. Again, yung ating pin mode 7, yan ay yung ating, let's say, electric fan. Okay, electric fan po natin yan. Okay, ito naman yung ating LED. Okay, now, tulad ng ginawa natin kanina sa push button natin, gumamit tayo ng if. Okay? So, which means to say that, remove ko lang tong delay. After ng code natin, ng serial print temperature, i-declare natin dito yung if function natin. If temp. Ano po ba yung gusto natin? Kapag mainit, anong value ng mainit? 40 po ba? 40 degrees Celsius po ba? So, kayo na pong bahala later on. Let's say, if temp is equal to or greater than or less than, kayo na pong bahala later on. If temperature is greater than 35 po ba ang mainit sa loob ng bahay? Sabihin natin
20,
yes, kasi say sensitive ang mga alaga natin. Tama ba, Ma'am Jen?
Oo, tama. Or 30 siguro, mainit na yun eh, kasi 26 normally.
30 na lang natin. If temperature is greater than or equal to 30, mainit na po ito. Anong gusto natin gawin? I-on po natin yung green na LED. Digital right. Ano po yung green natin? 13. Output natin yan ay high. I-on lang natin siya. Para magkaroon ng signal, makita na may-ari na nag-on yung green, ibig sabihin, mainit na sa loob ng bahay niya. And after mag-on, specific time, i-on na po natin yung ating electric fan. So ano po ba yung digital natin doon? Ay digital right.
Yeah, digital
Number,
right pin
7. And then, high or on. I-on po natin siya. So automatic na po siya. Of course, kung bumaba naman po yung temperature, Ma'am Jen, kailangan patayin po natin yung electric fan natin. Kung hindi, magsasayang tayo niyan ng kuryente. No? So, copy-paste lang po natin to first dito. And of course, kailangan natin i-edit yung code. And this should be low and low. Actually, ma'am, dyan pwede pa tayo magdagdag ng isang LED. Kung gusto natin na red,
Sige.
ay mainit. So, dagdagan ko
Mainit.
ito, ha?
Correct. Yun ang sasabihin ko sa'yo eh. Same minds talaga tayo eh.
O, dadagdagan ko to. Ngayon, bibilisan ko na lang kasi
15 minutes na lang tayo.
itong red po, itong red. Yan po yung mismong kapag mainit. Ito, resistor natin. Ayan. Then magdadagdag ako ng isa dito. Lalagay ko na lang sa pin 12 para magkadikit po sila. And then this one is red. Ayan. So mapapansin niyo po dito, green and red. Ngayon, sa code natin, kailangan palitan natin. Kung masyadong mainit, declare po natin dito yung red. This is 12. This is red. Green. And kung masyadong mainit po, no, anong gagawin natin? Etong 7 po, papalitan natin ng itong 7 daw. Itong 13, papalitan natin ng 12. Masyadong mainit, i-on natin yung red. Masyadong hindi na mainit, i-on natin yung 13. I-on po natin yung 13. Yung 13 po natin is yung green. Of course, kapag i-on natin yung isang LED, i-off din natin yung isang LED. Para sa ganun, hindi magtataka yung may-ari na bakit na dalawa yung naka-on. So dito, i-off natin yung green na LED. And then dito naman, copy-paste natin to. Yung 12 naman po, i-off natin. So, on yung 12, off yung 13. On yung 13, off yung 12. Tama ba, Ma'am Jen?
Tama,
Ayan.
correct.
Complete na natin yung smart house natin, smart house design circuit natin. So, kayo na pong bahala mamaya kung ilang electric fan ang gusto nyo dagdag, ilang LED.
Oo nga.
Okay? So, sige, isa-simulate na po natin to. Habang sinasimulate natin, papakita natin yung value. And ipapakita natin sa ating screen. Medyo malaki po aking screen. And para makita po ng iba. And po. So, ready for simulation? Start simulation po natin. Tingnan natin kung gagana yung at. It looks like meron tayong error. Hanapin natin. Ito po yung error natin. So, bakit po nagka-error? Ito, maganda nagkaka-error tayo, no? Kasi, makikita natin kung ano ba yung kulang ng ating program. Napaka-importante po na meron tayong, ayan, in function void loop, meron po tayong tinatawag na error expected, yung curly bracket natin. So, ibig sabihin po, meron tayong kulang ba? Or sobra na curly bracket? Hanapin po natin yon. Nandito po tayo ngayon. Line per line po natin titingnan. So, line 21, sabi po niya, ito po yung error natin. Ano kaya ang error na nandito sa program na to? Sige nga, tignan nga na natin, Ma'am Jen, sa palagay mo, ano ang error natin? Ayan. Kahit sa mga viewers po natin, baka may activities ni Ma'am Jen. Sir Wax.
Tayo mag-comment.
Ang tinatawag po natin tong debugging. Debugging section po tayo.
Yes.
Ano kaya ang error natin sa program? Tignan po natin.
Check natin yung mga pairing ng mga brackets kasi dapat yan ay may beginning and may ending.
Correct.
Brackets.
Yes. Ano kaya ang error natin? Ma'am Jen, nakita ko na yung error natin pero gusto ko makita sa mga viewers natin. Baka sakali lang. Siguro mga
baka sakali.
30 seconds.
Nakaka-apekto din yung gutom eh. Minsan duling na sila, nakakakita sila ng curly bracket kahit wala. Okay, tingnan natin.
Merong nag-answer. Ma'am Jen, sabi niya si Ma'am Elizabeth, curling sa digital right 13 high. Curling sa digital right 13 high. I think ang point ni Ma'am Jen, eto po ata. Which is correct. Yan.
Tama.
Error natin. Before yung ating digital right, yan yung error natin. So, tatanggalin po natin yan. Yan po yung error. So ngayon, sinaran po natin. Thank you, Ma'am Elizabeth. Meron po kayong 10 points para kayo. 10 points po. Si Ma'am. Dalawang certificate. I-start simulate. May error pa kaya to? I think wala na pong error. But then, as you can see in my screen, Church, na ang ating DC motor, i-zoom ko lang po, no? Nakikita niyo po ba dyan? Na umiikot po yung ating electric fan. Ang RPM po niya is 5,555. Yan po yung speed.
Baka ma-chop-chop yung doggy ko dyan, Chong, pag may blades yan.
you can see in my screen also, no? Yung red LED natin, Ma'am Jen, no, naka-on. Kasi yung
Yes.
value natin is 153. Ang taas po nito. Ngayon, i-click natin yung temperature sensor natin, Ma'am Jen. Bawasan natin to.
Asa ang ano?
Ayan, binawasan ko siya. Ginawa kong 20.
Okay.
Subukan natin. Ayan, nung nag-20 na po siya,
Very
yung
good.
yung ating electric fan, naka-off na rin.
Yung shaft.
And then yung
Yung
red
shaft
LED,
niya.
nag-off. Nag-on yung green LED natin.
Very good.
So ito na po yung smart circuit design natin para sa ating smart dog house.
Yan. Pwede rin yan sa ano, di ba, sir? Sa mga research nila. Yung mga
Correct.
simulation for testing hypothesis, no? So, dapat
Correct.
meron talaga silang application yan sa kanilang mga classroom. So, dati kailangan ka pang bumili ng mga ilaw, mga wire. Kung ikaw yung teacher, wala ka namang budget, ganito na lang. Kung meron din namang internet connectivity.
Yes.
And then, mas matipid siya kasi nga, kung may internet sa school or sa house, when you are doing your online classes, mas maganda.
Tama po, tama. Correct po yan, Ma'am Jen. Ayan po, cheers. So ito na po yung ating design for circuit ng smart dog house natin. So I think na-touch naman natin yung part na magde-design po kayo ng circuit. Now, dagdagan po ba natin ng isa pang DC motor, Ma'am Jen, no? Para sa ganun, let's say dalawa yung alaga nila, 2 kwarto. Dagdagan ko lang ng isa pa.
Pwede mo din magdagdagan ng mabilis na potentiometer yan para ma-chop-chop yung doggy ko. Kapag
Yes po,
sobrang
yes
tuloy
po.
naman ng aking
Ano po, Ma'am Jen?
pag sobrang tuloy ng ikot niya, baka ma-chop-chop yung mga dogs ko dun sa loob.
Yes po. So, pwede po ba nating dagdagan ito, cheers, ng controller para sa ganun, mabawasan po natin yung speed ng ating electric fan or ng ating mismong tinatawag na DC motor? Yes, the answer is yes.
Yes.
Gagamit po tayo ng potentiometer. Pero bago po tayo mag-proceed, check ko lang po ang ating YouTube. Kung meron po tayong mga katanungan, pwede na po kayong mag-type ng mga katanungan po ninyo. Kung wala naman pong mga katanungan, cheers, mag-proceed na po tayo sa potentiometer. Okay? So proceed na po tayo sa potentiometer, Ma'am Jen. Hindi na ako magdadagdag ng DC motor. So potentiometer, ito po siya. Ito po. So ito po yung pag-control natin ng speed. Pwede po yun. Okay? So ilagay po natin dito. Ayan. So meron pong 3 na wires na kailangan natin i-connect. Yung terminal 1, terminal wiper, and then yung terminal 2 natin. Yung terminal 1 po natin, Ma'am Jen, ito po ay negative. Lagay po natin sa negative. Then change po natin into black. Itong terminal 2 po natin, ito ay positive. Ito ay positive. So ilagay natin dito. Gawin natin red.
Yeah, for
And
power.
last thing po, kailangan po natin ng wiper. Ito po yung pag-control natin. This is analog po analog, hindi po siya digital. So i-connect po natin daw sa mismong analog sensor na analog pin. Lagay natin sa analog A1, analog 1.
Yes.
Change po natin to ng brown, brown.
Sige.
Ayan, so medyo magulo na po yung circuit natin kasi dumadami na. Pero sana gumawa kayo ng panibago kanina, no? Ayan, so nakasave naman po. Then next na gagawin natin, Ma'am Jen, is of course, kailangan natin ng variable. Ayan, balik tayo sa code, no? Kailangan natin ng variable. So i-declare natin yung variable natin as a public variable. Ipapangalanan natin ng int potentiometer or pot na lang siguro, Ma'am Jen, no? Pot value. This is just variable. Okay? Pot value. Okay?
Pwede kang gumamit ng kahit ano.
Yes, actually, pwedeng kahit A, pwedeng X, kahit ano po. Okay? And then, next na gagawin po natin, before po ng temp natin, i-declare po natin yung pagbato ng ating potentiometer papunta sa ating variable. So, we say na pot value is equal to, saan po ba nilagay yung potentiometer? Anong analog number? So, it should be analog read A1. Ayan po siya. Nilagay natin sa analog 1. Kaya sa ganun, kaya dapat nasa analog 1 din po siya, Ma'am Jen. Okay? And then, of course, dito, tatanggalin ko na tong if, Ma'am Jen.
Yes.
Kasi, manual na to yung pag-control natin. Tama?
Oo, tama.
Ayan. So, tatanggalin ko na po ito, no? Or, hindi ko na lang tanggalin muna. Sige, tanggalin ko na lang. Ang gulo ko rin, no? So, tatanggalin ko na siya.
Oh, medyo.
Tatanggalin ko na siya. And then, of course, yung ating value para sa ating DC motor. Ano po ba yung value ng ating DC motor? Ano yung gusto natin gawin sa ating DC motor? Okay? So, ang gusto natin gawin doon is,
mabagal.
yes, medyo mabagal po siya. So, dapat, ang ilalagay natin dito is, Ma'am Jen, I'm not sure kung pwede yung ganito sa DC motor natin, pero usually ang ginagamit natin si potentiometer to control LEDs, to control other components. But this is my first time to use potentiometer in DC motor. So, ito ay trial and error po na gagawin natin kasi gaya ng sabi ko kanina, ang ating DC motor po, cheers, ay nasa digital pin. Ibig sabihin po noon, hindi natin pwedeng gawan ng analog value kasi 1 or 0 lang. Tama ba, Ma'am Jen? 1 or 0 lang ang ating digital pin.
On-off lang kasi.
Ilipat siguro natin subukan natin ilipat ang DC motor natin, Ma'am Jen, papunta sa analog pin. Tatanggalin ko lang po. Kung gagana po ito. Okay?
Try na. So, anything you can experiment with this, no? Ang maganda dito, walang sunog factor. Kasi pag sa actual mo, tinry, naku, medyo sensitive.
Ayan, nilagay ko po sa analog 2, Miss, Ma'am, nilagay ko po sa analog 2. So, papalitan ko na itong 7 ng 2. Okay? And, of course, gagawin po natin, i-convert na po natin yung value ng potentiometer papunta sa value ng mismong DC motor. So, ang gagawin po natin dito is analog 1. This, gaya ng sabi ko, not temp. Kailangan natin i-declare int yung ating DC motor. Okay, semicolon. So, DC motor natin dito. Subukan po natin to kung gagana. Again, cheers, hindi ko po sure kung gagana po to, no? Put value kasi this is my first time to use DC motor and potentiometer. And then 0, 10, 23, 0, 120. Ito pong 120, ito po yung value. Okay, and then yan. And of course, ang serial dot print and natin, yung mismong value po, the speed natin. Yes. And enter ko lang po ito para medyo serial dot print ln or print. Ayan. So, i-display na po natin yung mismong value ng DC motor dito. Okay? DC, excuse me, motor. Ayan. So, ito, trial and error lang natin. Subukan natin kung gagana, Ma'am Jen. I think DC motor
try natin.
Digital right. I think this should be digital right. DC motor.
So, ito yung maganda kapag, lalo na halimbawa ito, assuming na yung participants natin ng ating students, no, we can ask for their opinions also if you have suggestions, opinions. So this is the time to collaborate with students. We have to learn with them. Yun yung maganda sa nag-STEM kasi maraming opportunities for students and teachers to learn either side. Kasi ako nga mas magaling mga estudyante ko kaysa sa akin, kaya minsan ako na yung nakikinig sa kanila, baligtad eh.
Opo. Ayan. So, ready na po tayo, no, na subukan yung ating mismong program. Nakalimutan ko pong isa pang code dito, yung ating value for the DC motor. Ayan po. So, i-run ko na po siya. Sana po ay gumana at walang error. Ayan. So, meron po tayong few arguments to function void analog right. Ito po yung sinasabi ko kanina, Miss Jen, na kapag ang isang component ay digital, hindi mo siya pwedeng gawing analog. Declare na analog. So, hanapin po natin yung error. Note, declared here. Sabi niya sa line 6 natin. Ito po siya. Yung ating line 6 kanina, ito po. Dito sa part ng pot value natin. Ayan. So, hindi po siya po pwede kasi na-i-declare as analog kasi ito ay designed for, for digital purposes. Kaya hindi po siya pwedeng mano-mano na control. Ayan. But, meron pong ibang components na pwede nating i-control ng mano-mano, Ma'am Jen.
Yes. Yan,
Ayan.
tama. Yan na yung comment ni Ma'am Elizabeth. Exciting talaga pong matuto ng Eureka Effect. Medyo lalayo lang kayo sa mga bata, no, pag ganyan. Kasi bigla silang tumataas ng kamay. Ako ilang beses na ako nasusunto kasi pag na-excite sila na yun yung Eureka moment nila, no. So as teachers, kailangan din po, at ganito po yung mangyayari, no, minsan sabay tayo nag-aaral ng mga bata, minsan kailangan talaga nating paghandaan yung aling components ang pwedeng digital lang, yung on-off lang talaga, aling components ang analog lang, at aling components ang analog na nagpa-function and digital na nagpa-function at the same time kasi may mga ganong components din na pwede sa analog pin. So, ang tanong ni Sir Ronald, pwede ba daw offline ang TinkerCAD, Sir Dom? Wala kang sound.
Ang TinkerCAD po ay online po siya, no need for installation, browser-based po siya. And sabi ni Ma'am Elizabeth, exciting talaga po matuto Eureka Effect. Yes po, totoo po yan. Ngayon, to go back to our discussion, DC motor po is digital. Meron pong analog components na pwede nating kapalit ng DC motor, which is, Ma'am Jen, pwede tayong gumamit ng servo motor.
Ay, wala pala akong sound. Tama, servo motor. So, yan yung mga minsan nile-let go na natin sa bata kung tingin mo gagana. Pero wag niyo pong pagpraktisan sa actual, ha? Dito lang kayo mag-practice. Baka magkasunog-sunog ang inyong board. Wala po kaming kasalanan. Ang tinuturo po digital. Okay? Ito lang tayo sa virtual.
Yes, tama po yan. Siguro, Ma'am Jen, mag-entertain na tayo ng mga katanungan kung meron.
Yes.
Regarding sa smart house na gagawin nila, consultation na ba tayo po ba?
Yes po. So, pwede pa siguro tayong, Sir Wax, pwede pa tayong konting extend, no? Mga 10 minutes. Sarap, napasarap eh. Sarap kasi maganda eh.
Totoo po yan, Ma'am Jen. Kung wala lang po akong talk mamayang 4 to 6, kahit
hanggang
5 o'clock po tayo.
Dapat maghapon talaga to, Sir Wax, di ba, Ma'am Maylene? Talagang, pwede nga lang di na kami umalis dun sa
Yes, kung meron pa po tayong part 2, hindi man about smart dog house, pwede po tayong mag-create pa ng another webinar para sa part 2 nito. Para sa ganun, mas marami po tayong pwedeng ituro sa mga participants natin.
Huwag mo kami hahamunin, papatulang ka namin, Sir Dom, kala mo.
Oo. Parang kulang nga 2 oras eh.
Oo, ma'am. Part sa sa next series pwede.
May tanong si Sir Ricardo Enriquez, may pang-alternative ba sa TinkerCAD para pwede po sa offline?
Ayun.
May alternative daw.
Sa previous experiences ko po, wala pa pong offline simulation tool na pwedeng gamitin for Arduino po, no? But then in other platform, meron pong virtual robotics kit po ata yun. Yung sa Lego, tama, Ma'am Jen, no?
Yes.
So meron pong offline.
Oo, maganda yung sinabi niya kanina. Di ba, Ma'am Maylene, tayo, LDD, no? Actually, yung LDD, if you create and you render, you can actually use it sa VRT. Kung ikaw nag-design sa LDD, tapos i-upload mo yon sa VRT na yun yung design ng robot na gusto mo, i-import mo, pwede. Pero, hindi natin pwede i-merge itong TinkerCAD natin doon. So, merong mga may mga simulator kaya lang may bayad. Ito kasing TinkerCAD free.
Yes.
Oo, doon tayo sa free.
So
we can, tama si Sir Dom. We will definitely have another part. Ay, shout out lang ako kay Teacher Ronald Cos, one of our robot technologists. Yan, ang nag-graduate sa Felta-Multi Academy. Our summa cum laude siya.
Yes.
Wow.
Yan,
And then,
sabi ni
rin siya ng alcohol dispensers. Dinodonate niya sa mga churches, sa grocery, using the Arduino. Yan. So,
yan, very good. Yan, nag-enjoy daw sila. Ito, nagbabasa ako ng comment kasi mga ayaw na nilang din kumain. Ako ayoko din kumain. Sabi nga, yes, please, more webinars, please. Pagbibigyan namin kayo dyan sa more webinars, parang wala naman kaming balak mag-stop, di ba, Mamay, Sir Wax?
Yes. Ang maganda kasi sa webinars natin, may output. So if you want to submit your output, please send it to Miss Jen. And bibigyan namin kayo ng another prize, para, di ba?
Kakalugin namin si Gearbox. Gearbox?
Ay, hindi.
Joke na. Okay,
natulog na.
Natulog na. Meron daw ba tayong part? Puro part 2. Opo, may part 2. Patingin daw ulit si Ma'am Annalyn ng code. Wala pa, Ma'am Ana, yung experimental code.
I-post na lang natin sa group.
Oo.
Post na lang.
I-post na lang dun sa Power or sa Felta. Ayun, I'm so happy na kayo ay marami natutunan kay Sir Dom. Kaya sa susunod, mas marami pa.
Thank you, Sir Dom. Talagang Sir Dom ang sagot sa mga agam-agam at mga kalituhan sa ating Ayan, kung yung Techbook Academy daw ba, Mamay, ay may online din. Kailangan hands-on kasi yung iba skills.
Ang natin, blended ang Techbook eh. Right now, ang robotics technology classes ay blended. So for now, meron siyang webinars, but you really need to have hands-on. So that will probably be at the latter part. Yun ang pinaka-culminating activity nyo kasi gagawa kayo ng mga robots eh.
Required yun.
Research, required.
Next Saturday, we will have the continuation of our webinar, no? And we'll be discussing about the 3D printing.
Yes. 3D printing, how to prototype. And then we will conduct actual demo. Although wala tayong mabibigay sa kanilang free na, Miss Jen, baka pwede gamitin yung LDD para pwede nilang gayahin yung ibang mga 3D models?
3D models, yes, I think so. Actually, yung next series natin is the 3D TinkerCAD 3D, same platform, no? Yung kay Sir Dominic kasi, yung circuit component, marami kasi siyang components. Pwede nating, marami namang ways. Doon sa design nga na gagawin natin, pwede naman silang magawa ng, wala talagang printer, walang devices. They can use other indigenous materials or clay or boards or cardboard, whatever they like. Ang mahalaga naman kasi meron lang tayong model. So, yung second part next week, ako yon. Ang dami ko ng research. Hindi ko alam kung paano ko pagkakasyahin sa 2 oras yung ni-research ko ng 3 linggo. So, i-compress ko. Yung kay Sir Dom, kailangan talaga ng part 2 pa niyan eh. So, ayun naman natin
Yes, for sure.
After nitong series natin, ang animal series, doon naman tayo kasi ang next series natin ay Smart Cities, di ba, Miss Mai? Smart Cities.
Yes, Smart Cities tayo.
Doon tayo kay Sir, more on sensor siguro yun, Sir Dom, no? Madaming sensor kasi. Yun yung Itong ating ngayon ay basic lang kasi gusto namin yung very detailed kasi hindi tayo pwede magkamali sa actual teaching and para alam din ng ating mga teachers kung ano yung dapat nilang paghandaan prior to actually teaching. Kasi kami nga ni Sir Dom, kailangan pa namin ang tagal-tagal na namin itong ginagawa pero every time hahawa ka ng simulator, feeling mo first time, di ba Sir Dom? Parang feeling mo laging first time. Ganon.
Saka maganda yung simulator kasi pagka actual na when we go back to the new normal, we're going back to our schools, you can now do your own Arduino robotics. Yun lang, ingatan nyo na yung motherboard. Maraming nasisira. Pero at least nakapag simulation na kayo, madali na sundan sa physical boards, saka sa physical kits.
Okay, marami pong nagtatanong sa ating mga participants kung ano daw po yung ating magiging output for today. At ano yung time frame?
Yung output natin for today, yun nga, sabi namin ni Sir Dom, Diba, nag-start tayo sa ano yung mga animals. How do we teach taking care of animals? Then, yung second series, this is actually our third series, no, Mamay? Second natin is yung design sa AutoCAD. And then, third natin is kay Sir Dom, which is the use of the circuit para maging medyo smart animal design yung ating ano. So, pwede silang for the meantime, wala pa naman yung actual 3D natin na kailangan talaga mauna yung plan mo for circuitry para pag nag-design ka sa 3D modeling, alam mo kung alin yung lalagyan mo ng butas na wall para doon mo yung enclosure nung iyong kasi ang i-design natin enclosure nung mismong device na ginawa mo. So papasok na doon yung math, papasok na yung geometry, 3D and 2D platforms. Aling part ang bubutasan para i-screwhin, tapos ikakabit sa ang part ng bahay or saan part ng doghouse kung gagawa ka, or ng hospital kung gagawa ka ng animal shelter, mga ganon. So, kaya kailangan na pag-isipang mabuti and planning, of course. Flow charting is a prerequisite dito, di ba, Sir Don? Kailangan turuan muna sila ng flow charting.
Yes po, yes.
Okay.
Nauubos yung boses ni Sir
Ating
Don.
mga participants very active no sa pag-participate sa ating mga activity for today. And of course, we would like to thank Mr. Dominic Sales for giving us his expertise no to share with our teachers nationwide. Thank you, Robo Guru Dominic Sales. Okay. So this webinar is recorded no via YouTube. Pwede niyo po puntahan yung mga channel po namin para maulit po ninyo yung ating mga activity for today's webinar. Okay? And of course, we're looking forward to see you next Saturday. Yes, Ma'am Jen?
Ano ulit channel mo, Sir Wax?
Prof. Wax Benson. Yan, punta lang po kayo doon. Prof. Wax Benson. Okay? So, I think that would be all for today. Overtime na po tayo.
Happy Father's Day! Advance Happy Father's Day!
Thank you.
Hindi pa father yan, bata.
Baby pa yan.
Father's Day.
Yes. Okay, so antabay lang po kayo sa ating mga pages no sa Felta, sa STEAMified at sa Power INC para po sa ating mga future activities. Felta and Power and STEAMified will continue to give free webinars for our teachers nationwide. No, this is free. Kaya samantalahin po natin kasi wala po kayong babayaran. Marami po kayong matututunan. In support, of course, with the Department of Education, no, sinusuportahan po natin yung DepEd para po magbahagi tayo ng kaalaman with our teachers, private and public. Okay? So muli, maraming pong salamat sa inyong lahat. Salamat po sa Gearbox Lab no, from the US, si Sir Peter at saka si Isabella for having with us this morning, this afternoon, and Felta, STEAMified, and Sir Dominic. Magandang tanghali po sa inyong lahat.
Thank you po. Thank you. And Ma'am Chen.
Thank you. Happy weekend.
Salamat, Sir Dom. Part 2.
Thank you, Dom.
Part 2, ano natin i-set up natin ng schedule.
Yes.
Plan.
Okay.
Okay. Bye-bye.
Bye.
Bye-bye.